So I always like to start simple. So we'll start with something here, and this right here is going to test your understanding of area and perimeter. So we're going to see how you answer this question. So we have a rectangular lot that measures 125 feet by 185 feet that is completely fenced. What is the length in feet of the fence? I want you to remember that anyone can answer any question here. You don't have to be a specific grade. So I did not put any grade really because I want you to feel free to answer any question. So we're looking for a rectangular lot that measures 125 feet by 185 feet, and that is completely fenced. What is the length in feet of the fence? I'll give you a few moments to try to answer this question, and then we'll do it together. Okay, let's go ahead. I don't see a response yet. And so we'll go ahead and get started with this question. And then I'm sure as people get in and get familiar with what we're doing, you'll be able to participate. So we have a rectangular lot. So let's draw a rectangle. And it measures 125 feet by 185 feet. And we're saying that the lot is completely fenced. What is the length in feet of the fence? So the way you want to look at that is, if it's completely fenced, it's going to look like this. It's going to have the same dimensions as the lot. So when you're looking at here, it's asking you for the length of the fence. So that simply means we're looking for the perimeter. And your perimeter is the path around an object. So the path around an object, or you can say the length of all the sides of an object. So in this case, we're going to just, perimeter is going to be 2 multiplied by length plus width. Or you could just add all the sides. You could make this 185 here and 125, and then you can add them up. But this I find to be a lot easier to do. So let's go ahead and add 125 and 185. 0. Bring 1 up here, 1, 3. So we multiply 2 by 310, which is going to give you 620. Are there any questions on this topic? So when you see what is the length of this is actually quite common on both the SAT and the ACT. And what they're trying to do is make sure that you understand what the perimeter means. And if it's a circular object or a circle, it would say the circumference. It would also use the length though, but you just have to remember that in that case, they're referring to the circumference. Okay, if you have any questions, feel free to leave them on the chat and I'll get to them for sure. Okay, so now we have, if x is a real number such that x cubed is equal to 729, then x squared plus the square root of x is equal to what number? So x cubed is equal to 729. We want to find out the value of x squared plus the square root of x. Lots of different ways to look at this actually. I would like to see how you all think about this question and how you respond. So x cubed is equal to 729. So that simply means that x multiplied by x multiplied by x equal to 729. So we need to find out the value of x. That's one way. That's the way I prefer to go. I'm sure there are lots of other ways to do it, but that's the way that I think is you would have a lower chance of making a mistake. Okay, let's go ahead and attempt this together. So this is 729 and we're going to, so this is 729 and we want to find out the number that when you cube that number you get to 729. So I'm going to go here and I'm going to have 3. I'm going to create a factor tree here so that I can come up with the number that when you cube it, you get to 729. So if I divide 729 by 3, I get 243. If I divide 243 by 3, I'm going to get 81. If I divide 81 by 3, I'm going to get 27. 27. And then 27 is going to be 3 multiplied by 9. And then 9 is going to be 3 multiplied by 3. So let's count the number of 3's. 1, 2, 3, 4, 5, 6. So you have 729 is 3 multiplied by 3. You have it 6 times. 1, 2, 3, 4, 5, 6. Now we're looking for the cube root. So what we're going to do here now is this. The cube root of 729 is going to be the same as the cube root of 3 multiplied by 3. And then you have 6 of them. And when you have this situation, what you're going to do is the cube root simply means that we're going to have groups of 3. So we have a group of 3 here. We have 3 3's here. So we're going to get one number out of it to represent that group. And then over here, we're going to get one number out to represent the group, and we can multiply. So the square root of 729 is going to be 3 multiplied by 3, which is equal to 9. So now we have x is equal to 9, and then you can use that to solve this right here. So if x equal to 9, x squared plus the square root of x is equal to 9 squared plus the square root of 9. 9 squared is 81. Square root of 9 is 3. So you're going to get 84. So this is how you would answer this type of question. Do you have any questions? Any thoughts? All right. Thank you for answering. 84 is our answer. So if you have any questions or you have a different take on this type of question, let me know. I am always here to learn from you as well. All right, let's go to the next question. What is the slope-intercept form of 6x minus 2y minus 4 equal to 0? What is the slope-intercept form of 6x minus 2y minus 4 equal to 0? Remember here, when you have slope-intercept form, it's simply this, y equal to mx plus b. That is your slope-intercept form. M is your slope and B is your intercept, and it's actually your y-intercept. So we're looking for the slope-intercept form. If you have any questions about what we're doing, please feel free to ask, and I'll be glad to help you with that. I'll be glad to answer any question you may have. Once we finish this, we're going to do some science reasoning. When we finish this math portion, we'll do some science, and if we have some more time after, we'll do some more math. All right, so let's go ahead and answer this question. So our goal here is to rewrite this equation in the form y equal to mx plus b. One way you can actually also tell, one of the good things about this test is if you look at the answers, you can get an idea of what they're asking you to do. So you can see all the answers are in that form, in the form y equal to mx plus b. So now what we're going to do is rewrite this. So we're going to make sure that we have y on the left-hand side and all the other terms on the right-hand side. So what I'm actually going to do is I'm going to move the y off because it's equal to, it doesn't matter how you go about it. So I'm going to add 2y to both sides of this equation. So I have 6x minus 4 equal to 2y. And then what I'm going to do now is divide both sides by 2, because I need to make sure that I have the coefficient of y has to be 1. So I'm going to divide by the number to the left. So we're going to now have 6x minus 4 over 2. What we can do to actually divide this is to factor the numerator here. So we're going to have 2 as a common factor here, greatest common factor, and you have 3x minus 2 over 2 equal to y. And then you can cancel this out, and then you have y equal to 3x minus 2. Y equal to 3x minus 2, and that's going to give you h. There's another way you could have done that. I just think it will take longer. One of the important things to remember when you're writing your SAT or ACT is find the fastest way to solve problems so you do not lose time. It's very easy to get so involved in a question and then you lose all the time for other questions. So when you have questions like this, look for any question that you come across on this test, look for the simplest and the fastest way to answer the question. All right, so I have a puzzle after this. If you have any questions, feel free to leave them in the chat, and I'll get to them, and I'll let you know when I can answer them. So here's our first puzzle. I wanted to do something that was more logical than very math driven in terms of the puzzles today. The puzzles today are not too complicated. So they're more logical reasoning because of the SAT and the ACT. So if 3 cats can catch 3 bunnies in 3 minutes, how long will it take 100 cats to catch 100 bunnies? Three cats can catch 3 bunnies in 3 minutes. Okay, Daisy, we'll do one more question like that after we get through this puzzle. So we have 3 cats can catch 3 bunnies in 3 minutes. How long will it take 100 cats to catch 100 bunnies? Anyone have an idea? There's really no math to it, but I'm sure some of us are probably doing some math, and it's probably going to get complicated if you do the math. But think about it this way. If 3 cats can catch 3 bunnies in 3 minutes, so how long will it take 1 cat to catch 1 bunny? How long will a cat take to catch 1 bunny? All right. What's going on today? I'm not seeing a lot of participation. 100 minutes. Okay, that's one approach. Okay. Thank you for responding. That's good. I always like students responding. So it's 3 cats, 3 bunnies in 3 minutes. So one cat actually, remember that they are working on their own. They're not working together. So they're working on their own. So a cat is catching a bunny in 3 minutes. 3 cats will catch 3 bunnies in 3 minutes. And so therefore, 100 cats will catch 100 bunnies in 3 minutes because it takes the same time for 1 cat to catch a bunny. So that's just the logic behind it. It's like saying if I'm trying to boil some eggs, and if I can boil 5 eggs in 15 minutes, how long will it take me to boil 10 eggs? If they're in the same pot, it's still 15 minutes. You're not going to boil it for longer, for 30 minutes because it's 10 eggs. So that's the idea. So it's 3 minutes. The answer here is 3 minutes. It's a logical reasoning question. Okay, so what I'm going to do now is, because I have a request to solve some more questions like the previous one about writing equations in slope-intercept form, I am going to attempt to do that. Give me a second. Let me pull up a page. Okay, so the question here, I'm going to come up with a question. Write the equation 5x plus 4y minus 3 equal to 0 in slope-intercept form. So we're going to write the equation 5x plus 4y minus 3 in slope-intercept form. So what I'm going to do here is, you have to always remember that you're writing it in the form y equal to mx plus b. So this is your end goal. You have to have just y. So I have 5x plus 4y minus 3 equal to 0. What I'm going to do in this case is I'm going to add 3 to both sides first. So 5x plus 4y equal to 3. Then I'll subtract 5x from both sides. So I have 4y equal to negative 5x plus 3. And then we can now divide both sides by 4. We divide both sides by 4. So y is equal to, remember when you divide a fraction by 4, you're dividing every term in that fraction by 4. So it's going to be negative 5 over 4x plus 3 over 4. So in this case, you may be asked to find the slope and the y-intercept. Your slope is going to be negative 5 over 4. Your y-intercept is going to be 3 over 4. So that's what this equation is. Does this help? Does this help you with your understanding? I didn't add on, but it just depends on the way the question is written. In that last question, let me go back to it so I can explain a little bit better for you. So in this question here, the reason why I did that is because I have a negative 2y here. So if I just add 2y, it gets it out of here and just moves it to this right-hand side. So that way I don't have to worry about this. I don't have to worry about the others. The other way you could have done this is, which will take longer, and that's why I didn't do it this way. But if I have 6x minus 2y minus 4 equal to 0, I could have added 4 to both sides first. So it's going to give me 6x minus 2y equal to 4. Then I subtract 6x from both sides. So I now have minus 2y is equal to negative 6x plus 4. And then I have to divide everything by negative 2. And then now we have y equal to 3x minus 2. So you can see that regardless of how you go about it, I just found the easiest way to do it. And how you're probably thinking, how do I find easy ways? Just keep practicing. Just take a few questions like this, walk through them. You will come up with a method that would work for you and make you faster. I could have done this in about the same time as this on my own, but since I'm trying to show you the fastest way to do it, I decided to do it the other way. Is it a bit clearer to you? Okay, well, I'll try to look. If we have some more time, we'll do a few more at the end. But I want to get to some science, and then we'll get to, when we have some time at the end, we'll be able to do maybe 1 or 2 more examples like this. So I want to remind you all that during this summer, as like I said at the beginning of this session, during this summer, we're going to be offering some customized programs for math, science, and English. We're going to be doing ACT and SAT as well. And this is going to be, we're going to offer a program where students that are in the same group learn together. So if you're in 5th grade, you will learn with only 5th graders. If you're in 6th grade, you will learn with 6th graders. And if you want science or math, you're going to learn with students that have the same interests. So it's not going to be like what we have now, where we have 8th graders and some college students. We're going to have students in the same grade and learning the same thing, so we can focus on helping you get caught up from where you may have left off in the previous semester, and also prepare you for your next school year. So if you're interested, I encourage you to join us. If you're interested, reach out to us, and we'll be glad to help you, give you some more information on how to get signed up, and dates and times and all of that good stuff. So it's going to be from June 8th to July 31st. I'm actually looking forward to this program, and everything will be done online through Zoom, and I think it'll be a good time. Okay, so we're going to do some science now. On the SAT and on the ACT, you actually have a science component to both exams. So what we're going to do now is we're going to look at this example. There are 5 questions based on this graph or this table, and we're going to use that to explain to you how to read this type of questions. This is actually an old ACT exam, and this actually does show up also in the SAT, but in a different flavor, but very similar. So I want you to spend probably about a minute or so to read the graph and the table, and try to understand what the table is about, and then we can answer some questions together. So a solute is any substance that is dissolved in another substance, which is called a solvent. So these are important things to note. A student tested the solubility, which is the measure of how much solute will dissolve into a solvent, another important word there, of 6 different substances. The solubility of a substance at a given temperature is defined as the concentration of the dissolved solute that is in equilibrium with the solvent. Table 1 represents the concentration of dissolved substances in 100 grams of water at various temperatures. The concentrations are expressed in grams of solute per 100 grams of water. And so that's what this table This is just an explanation of what the data in this table represents. So we're going to answer. Are you all done reading the science passage? Do you understand it? So here we're looking at, this table is talking about solutes and solvents, and we're looking at the concentration of a solute in 100 grams of water and at different temperatures. So I'll give you some time to just take a stab at it and let's see what you come up with. The first question here is, according to table 1, the concentrations of which of the following substances varies the least with temperature? Which of these substances varies the least with temperature? So just look at the table and see if you can come up with any of these substances. We notice here that you have 4 choices, so you don't have to look at you don't have to look at the other 2 because you only have 4 choices. This is a very typical type of ACT science question. And in the ACT, you have 3 types of science questions. This is what we call the type 1. So you have a table and you have to just interpret the table and answer questions based on that table. So this is very common in the ACT. So does anyone have an idea of what this answer would be? The concentrations of which of the following substances varies the least with temperature? So the hint here, let me give you a hint as you're looking at it. You're looking for which of these does not change that much as the temperature changes. That's all. Which of these substances does not change a whole lot as the temperature changes? All right. Okay, Adesi is answering. That's good. So let's look at this answer here. So we have HCl. Let's look at HCl. We have here, as the temperature increases, you can see there's a lot of change in temperature here. And with the important thing for you to remember is that in the science, you don't need a calculator. So if you're having to calculate, you're doing too much. So you can just look at it and see that, okay, I can see like there's a difference in the temperatures, in the concentration of the solute as the temperature increases. So that rules this out. Then let's look at NH3. NH3, we have 90 to 55. You can already see that there are big changes, so that rules this out. Now let's look at NaCl. So we have 37, 37, 38, 38, 39, 40. So there's really not that much change happening. So we're going to put an asterisk here just to make sure that that's where we think we're going. And then we look at KCl. You can see here that we have increases that are more significant or larger than what's happening with NaCl. So this is going to be your answer to the question. So good job, Anastasia and Adesi. Good job. Does anyone have any questions? Just remember that if you have any questions as we proceed, just ask, and then I'll be able to go back. I will be willing to go back and answer them for you. So this is the same table, is the same question I just had to, I'm repeating the table so that for each question, so you can have, you can see them while you're answering the questions. So here we have the graph below represents the relationship between concentration and temperature for which of the following substances. So you're going to use the table as your reference to see which of these substances matches the graph. Let's see, what do we have here? Which of these best represents the relationship between concentration and temperature for which of the following substances? So we're going to, the hint here is just look at each of the substances in the answers and then see which one of them really is, which of them more closely matches what's in the graph. Okay, so let's take a look. Let's look at the graph and look at the options. The good thing with this test is that they give you some ideas of what possible options to explore. So if you look at F right here, let's start with F. HCl. So let's look at HCl. What happens at HCl? At 0 is about 83. So I can see that, okay, that's a good. And then at 20, you see that's 72. So you can see that it's sliding down. And then at 100, what do you have for HCl? You have about 43. So I can see that that's a potential answer. Okay, Adeze, wonderful. Anastasia, wonderful. So HCl is a potential answer. Then we look at NaNO3, which is this one right here. At 0, you have 72, which you could say, okay, maybe that's close enough. But at 20, you have 86, so it should go up. So that is not going to work. NaCl, you have 37, 37. So you can see here that nothing really changes. So you should have more of a straight line. So this isn't going to work. And then KCl, you have 28. You have an increase, but this shows a decrease. So this isn't going to work. So this is your answer. What I'm doing with you is I'm showing you a method that I like to introduce to my students is the process of elimination. So what your goal is using this method is to find a way to eliminate bad answers so you end up with the right answer. And that process never fails. If you can learn to use that process for your SAT, ACT, and even when you get past college and you're trying to become a graduate student, your GRE, all of this stuff will work. All right, good job so far. So now this is our next question. So the data shown in table 1 support the conclusion that for a given substance, as the temperature of the water increases, the amount of solute that can be dissolved, and these are your options. Does it increase all the time? When you say increase only, it means that for every single substance, you should have an increase. When you say decrease only, it means that for every single substance, I want you to remember that when you select an answer, it must be true for every single part of the graph or of the table. It must be true all the time. So does it decrease only? Does it vary and has a trend depending on the substance? Or does it vary but no specific or no particular trend? So those are the options that you have. Okay, so I see D as an answer. All right. I'll wait for one more response and then we'll get going with this one. So here we're asking, what is the specific behavior of this table? So what conclusion can we arrive at? What conclusion can we come to based on based on the data in the table? So let's look at the options that we have. The first one says it increases only. Let's see if that's true. I can see an increase here. I can see an increase here, but there's a decrease here. So that doesn't work. And that also means decreases only doesn't work. Now we're going to look at the next C. It says varies, but there is a trend depending on the substance. What this means is that it may increase or decrease, but for each of these substances, they have a specific way that things are going. So if you look at KCl, for example, you can see that as your temperature increases, your concentration also increases. You look at NaNO3, as your temperature increases, your concentration generally increases. Now you look at HCl, as your temperature increases, what happens? It decreases in the concentration, and then you do that for each of the different substances in this table, and you can see that for each of these substances, if there's an increase, there's a consistent increase. It may not increase by the same number of value, but you can see a consistent increase. When you look at the decrease, there is a consistent decrease. It may not decrease exactly the same way, but if you follow, you can see that it's actually decreasing consistently. So what that means is that we have a variation in behavior, but the trend actually depends on the substance. That's the way you want to answer this type of question. There is a variation in behavior, but each substance behaves differently. And in its behavior, it's consistent in whatever behavior it exhibits. So that's why the answer is C. The reason why I didn't bother with D is that D says it varies, but there's no particular trend, and that is not true, because when you see questions where it says there's no particular trend, what that means is that in some instances on the same substance, you can have an increase and a decrease. That's what it means by no particular trend. If you have a consistent increase, that's a trend. If you have a consistent decrease, that's another trend. So that's what you want to look out for when you're answering a question like this. Just take note, some of the things I'm telling you they are the tricks that you have to understand, the strategies that you have to understand to be able to do well in this type of tests. SAT, ACT, the strategies are similar. All right, next question. So according to the table, HCl will most likely have which of the following concentrations at 70 degrees Celsius? HCl will most likely have which of the following concentrations at 70 degrees Celsius? Okay, let me give you a few more moments to attempt this. Based on this table, HCl would most likely have which of the following concentrations at 70 degrees Celsius? So we're looking at HCl, which is right here. So that's the column that we're going to pay attention to. So I see J. Okay. Okay, good attempt. All right, let's see. Let's take a look at it. HCl at 70 degrees. So 70 degrees is going to be midway between 60 and 80. So 70 is going to be right here. So when you look at this, you're looking for a number that is between 48 and 55. So now that you know what that number is, and be sure to know that it's going to be somewhere in the middle of 48 and 55. So we're going to look at, so I would say roughly about 50 or 51 is going to be where your number would be. So let's look at our answers, and we can see here 48.5 will not work because it's too close to 80. So it's going to be maybe a higher 70, probably 78 or so. But now we have 51.5. You can see that that's almost in the middle of 55 and 48. So that's how you would answer a question like this. I'm just going to say again, these are very common type of questions. Very common. Anastasia, great job. They're very common. So I want you to understand these techniques so that when you have to take this test, you will not have any problems with these questions. And then the last one for this passage. So it's where a scientist wants to dissolve at least 50 grams of NH4Cl in 100 grams of water in order for the solution to be a proper concentration for use in an experiment. A reasonable minimum temperature for the solution would be, so we're looking at NH4Cl, so this is all we care about, that column. So we have 50 grams of NHCl, so that's your concentration, 50 grams of NH4Cl in 100 grams of water. So that's going to be your concentration. We want to find out under what temperature can we get 50 grams of NH4Cl in 100 grams of water. All right. Don't forget, during this summer, we're going to be doing a lot of this type of questions in our classes. We're going to have our SAT, ACT class. It's going to be a group class. We like the group sessions because it allows you all to participate, learn from each other, and also gives me an opportunity to learn from you and to learn more about the way that you look at problems. But most importantly, for us to learn together as a group and make sure that you're ready for the SAT. I'm seeing that the SAT may be kicking off somewhere between September and December. I don't think I don't think it's solid yet, but it's going to be happening in the next school year. So this is an opportunity for you to prepare without the pressure of knowing that thinking you have to get it done so quickly. Because without the COVID, you would have had to prepare for an SAT exam, and I believe ACT in June, August, and September, but you don't have that pressure right now. So our program is for you to get an opportunity to just prepare at your own pace. Okay, so do we have an answer? So what you need to do, simple hint for you here is look at the column with NH4Cl. And just take an estimate, look at 50 grams, we're looking for 50. So here you're looking for where 50 would fall in. So just look around here and ask yourself, for each of these temperatures, could you get about 50 grams per 100 grams of H2 or 100 grams of water? So that's all you're going to look for. So we're looking in this column right here, this column here, and we're going to see where 50 will best fit. Okay, I'll give you like maybe about 30 more seconds, and then I'll show you exactly what to do. So I have C, okay, good. Thank you for attempting. So 35. So one thing I want you to also see as you're answering the question is, you look at NH4Cl, pay attention that as the temperature increases, what's happening to the concentration, it's also increasing. As the temperature increases, so that means that if you want 50, you cannot have 50 before 40 degrees because 50 is greater than 46. So you can't have it anywhere before 40 degrees. So it's going to be a temperature above 40 degrees. And then just looking at your answer of a temperature has to be above 40 degrees to get 50 grams of NH4Cl, then you look in your answer choices and look for the one that is above 40 degrees. So you're saying subtract 11. That is true, but I want you to remember you are not expected to do any math, really. Almost minimal. You shouldn't have to even, do any kind of mathematical calculation in this type of test. That's not, what they're trying to test is how you think through scientific problems or scientific tables or scientific data. That's all they're testing, but not for you to really go deep into the data. So that's one thing to be aware of, because if you do that, most likely you won't be able to finish the test, because the test has 40 questions, 35 minutes, and 7 passages like this. And some are actually longer than this. So just remember that. So now when we look at it, we see 50 grams of NH4Cl. When I look at NH4Cl, as the temperature is increasing, what's happening to the concentration is also increasing. So that means that my 50 is going to be somewhere around here. It's going to be after 40, but before 60. So the best answer for that is going to be D. So pay attention to those type of little details and those techniques, that they're going to be helpful to you. So I know we have a few more minutes, but I think we have enough time to do one more example for Adeze, that she wanted us to do an additional example on converting an equation to the slope-intercept form. So let's go ahead and try one more, and then we'll do our last puzzle for the session. Why didn't you select it? I'm actually curious to know. Why did you second guess yourself, or was there something in the table that led you to select a different response than what you had what you had in mind to select? So while you're answering, we're going to come up with another equation. So let's go with 6x minus 3y plus 7 equal to 0. We're going to write that in slope-intercept form. Just remember that a lot of these topics, if you go to our channel, you will see we have a SAT playlist that has a lot of SAT topics and also has different ways to answer some old SAT exams. And I believe there should be one for ACT as well on our channel. And then all these topics, we have videos for them as well. And we break them down to make sure that you understand from the basics until we build up to where we think you need to be at the end of that video. So feel free to reach out and to our channel and then watch some of those videos. They will help you. And if you've not already subscribed, please go ahead and subscribe so that when we have these sessions, you'll get notified. And so let me show you what to do here. So this is similar to the one that we did first on the SAT or ACT test. So what I'm going to do here is I have 6x, I have 7, and I have negative 3y. Now, what I need to remember is that for me to move, if I move negative 3y out of here, it becomes positive on the other side. So I need to have it in y equal to mx plus b. So the simple thing to do is just to add 3y here, to add 3y, and then we have 6x plus 7 equal to 3y. So now I have a form that looks like this already. I don't have to do a lot of work, and then I can divide by 3, divide both sides by 3, and then I have 6x over 3 plus 7 over 3 equal to y. And so 6x divided by 3 is 2x plus 7 over 3 equal to y. And just for the standard way of writing the equation, we're going to just rewrite this as y equal to 2x plus 7 over 3. And that's going to give you the answer to your equation in slope-intercept form. So feel free to reach out if you need more examples. We have, like I said earlier, we have playlists on algebra. This is an algebra 1 topic. So we have a playlist on algebra. We have also playlists on SAT. So if you have any questions, feel free to reach out to those resources. And then in our next sessions, you can also ask the questions that you may have. And don't forget that during the summer, we'll have an opportunity for you to be able to ask as many questions as you want that are tailored to your specific need. And then before we leave, I'm going to give you one more. Oh, you're welcome. You're welcome, Adeze. Before we leave, I'm going to give you one more puzzle, and then we'll call it then before we end our session. So write an equation using the numbers below, or the below numbers, and mathematical symbols. Write an equation using the numbers below and also the mathematical symbols below. One thing I want you to know is that you can, everything you need is here. You don't actually need any external symbols or anything. These are the only things you need to get an answer. Any ideas? All you need to do is you need to add, and you need to add, and I'm going to give you a hint. You can actually have an exponent. You can actually have an exponent in your equation. You can actually use an exponent, or rather, let me say it this way: you're going to need an exponent in this one. Anybody have an idea? Okay. So let me show you what this is going to be. I know we're out of time. So this is going to be 4 plus 5 equal to 3 squared. So you can see here we have our 2, 3, 4, 5 plus and equal to used up. So that's all that's all you have to do for this one. I wanted to select puzzles today because we're doing SAT, ACT that were more about logical reasoning and not really about doing a lot of addition and subtraction. So that's all we have for today. And I want to thank you for joining me today and for the hour that we spent together. And I hope that you have learned something. I hope you've enjoyed this session. I have enjoyed this session. I know today was a bit low on participation, but I understand that. And if there's any way that if there's any way that we can make these sessions more helpful to you, please drop us an email at info@mathis.com, or you can send us a text at 240-688-5447, or you can go on our website and you can send us some information through our contact page. So we'll welcome any kind of feedback that you have for us to make this better. We want to make sure that you as a student is getting the best out of this experience. And so thank you again for joining us. Sorry about the audio issues at the beginning, and look forward to hanging out with you next week, and enjoy a blessed weekend. And bye for now.
Hi, my name is Arifa Delasimo, and I'm making this video today to tell you about a wonderful opportunity you have to invest in yourself and your own future career goals by enrolling in Matthews Tutors. I'm currently a freshman student at Columbia University in the city of New York, an Ivy League institution, where I am studying neuroscience and behavior on the pre-med track. I personally don't believe that I would have had the ability to call myself a Columbia student had it not been for the efforts of Matthews Tutors all those years ago. When I was in high school, I struggled with math, and I knew that I struggled with math. Math filled me with fear, and I wasn't confident doing it. But after just a few sessions with Matthews Tutors, not only was I instilled with the confidence to go forth in whatever math classes I chose to take, but I was able to increase my ACT score by almost 10 points, helping me earn a super score of 35. With those numbers, I was able to get accepted to all 16 colleges I applied to, including, but not limited to, Cornell University, Georgetown University, Tulane University, Duke University, and the college I currently attend, Columbia University. Matthews Tutors is going to do everything that they can to help you. That's what they did for me. But not only are they going to help you be a better student, they're going to continuously check in on you. I know that I personally received a lot of messages of support from them during my first semester of college, which was one of the hardest semesters I've ever experienced as a student. Matthews made sure that I had the confidence to go forth and pursue my own academic goals, but they also helped me increase the numbers too so that I could get where I wanted to be. And I know that they can do the same thing for you if you give them a chance. Thank you.
ACT 2017-18 math test. We're going to look through questions 1 to 5. Question 1. The blood types of 150 people were determined for a study as shown in the figure below. If one person from the study is randomly selected, what is the probability that this person has either type A or type AB blood? So type A, for that we have 67 people. Type B, we have 15, but we're focused on type AB, which is 6. So the probability of type A or type AB is the probability of type A plus the probability of type AB. So the probability of type A is going to be 67 over 150. So that's number of type A divided by the total population. And then look at type AB, sorry. We have the number here over the size. So this is going to give us 73 over 150. The monthly fees for single rooms at 5 colleges are $370, $310, $380, $340, and $310 respectively. What is the mean of the monthly fees? So the mean, I'll say average, or the mean, is going to be equal to 370 plus 310 plus 380 plus 340 plus 310, and we're going to divide by the count, which is 5. When you add this up together, let's do that on the side. 370 plus 310, we get 680 plus 380, we get 1060 plus 340, 004 for 1400 plus 310, we get 1710. So we have 1710 divided by 5, and we show the work. I'm a big fan of avoiding the calculator as much as possible because sometimes it slows you down. So this is 3, get 15, 21, 4, 20, we got 10, that's 2, 10. So we have $342. On a map, on a particular road map, 1/2 inch represents 18 miles. About how many miles apart are two towns that are 2.5 inches apart on this map? So 1/2 inch represents 18 miles. So what I'm going to do now is I'm going to convert 2.5 to an improper fraction. So we have 5/2 inches equal to, so what we see here is from 1/2 to 5/2, we're multiplying by 5. So we're going to also multiply by 5 here. So 18 multiplied by 5, we have 90 miles. So we have F is equal to C d to the third power. So F is 450. We're trying to find the value of C, d to the third power. So this is going to give us 450 equal to 1000 C. So we divide both sides by 1000. So we have C is equal to, let's cross this out, 0.45. Now we have f of x equal to 3x plus 7 squared. F of 1 is 3 times 1 plus 7 squared. So that is 3 plus 7 squared, or 10 squared, which is 100. The ACT 2017-18, that's the free test. We're looking at the math portion, 6 questions, 6 to 10. So Jorge's current hourly wage for working at Dentist Smiles is $12 an hour. Jorge was told that the beginning of next month, his new hourly wage will be an increase of 6% of his current hourly wage. What will Jorge's new hourly wage be? So what we're going to do to get, so the new hourly wage, so new wage is going to be equal to current wage plus increase. Okay, so let's look for the increase. The increase is 6%. So we have 6% multiplied by $12. So that's going to give us 72 over 100, which is 72 cents, or $0.72. So his new wage is going to be the current wage of $12 plus the new increase, or an increase of 72 cents. So this is going to give us, just for good measure, let's do this. So we have 2721. So we have $12.72. The first term is 1 in the geometric sequence. And what is the 7th term of the geometric sequence? So the nth term of a geometric sequence is the first term multiplied by the ratio to the power of n minus 1. So how do we get the ratio? So here we have a equal to 1, and then r is equal to -3 divided by 1, which must also be equal to 9 divided by -3, and must be equal to -27 over 9. for this to be a geometric sequence. So r is equal to -3. So the 7th term is going to be 1 multiplied by -3 to the power of 7 minus 1, which is 1 multiplied by -3 to the power of 6, and that's going to give us 729. The shipping rate for customers of ShipQuick consists of a fee per box and a price per pound for each box. The table below gives the fee and the price per pound for customers shipping boxes of various weights. So Greg wants ShipQuick to ship one box that weighs 15 pounds. What is the shipping rate for the box? So we're looking at this row right here. So we got 15 pounds. So shipping rate is equal to fee plus price per pound. The fee is $10. The price per pound is going to be 0.65, but then we're dealing with 15 pounds. So we're going to multiply by 15. So this is going to give us $10. And if you compute 0.65 by 15, we're going to get 9.75. For good measure, let's go ahead and show how to do that. 0.65, 15. So this is going to be 532. It's going to be, put a 0 here, have a 5, we have a 6, 5, 7, 9. We got 2 decimals, 1, 2. So now we have 10.00, 9.75. We add this together, 5, 7, 9, 1. So we have $19.75. A computer chip 0.32 centimeters thick is made up of layers of silicon. If the top and bottom layers are each 0.3 centimeters thick and the inner layers are 0.02 centimeters thick, how many layers are there? So we got 0.32 centimeters for the whole chip. Top layer, so I'm just going to say top layer is 0.03. Bottom layer is also 0.03. What is going to be, how many layers are there going to be between the top and the bottom? So let's do that. So sum of the top layer plus bottom layer is 0.03 plus 0.03, which is going to be 0.06 centimeters. Now we want to find out how many layers are between. So let's see, what's the thickness of the space between the bottom and the top layers? So let's look at thickness. It's going to be 0.32 minus 0.06. Let's do 0.32 minus 0.06. We have 0.62. So this is 0.26 centimeters. But each of the inner layers is 0.02 centimeters thick. So number of layers is going to be the thickness divided by, so that's the thickness of all those layers divided by the thickness of each of the layers. So we're going to end up with 13 here. So here's what you do: 0.26, 0.02, I'm going to move 2 spaces right here, 2 spaces right here, so I end up with 26 divided by 2, and then we have 13. Number 10. The table below shows the number of cars Jing sold each month last year. What is the median of the data in the table? First step in getting the median is to actually arrange the numbers in increasing order. So let's do that. Let's look at the ones first. We have 13, then we have 15, then we have 16, 19, 19, then we start with the 2s. We have 22, we have 25 twice, then we have 26, and then 27, 28, 29. Let's make sure we accounted for all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we've accounted for all the data. Now what we need to do is we're looking at an even number distribution. So what we end up doing with the even number distribution is we divide 12 divided by 2, which is going to give us 6. We're going to subtract 1 from that, so that means that we're dealing with 5 on each side. 1, 2, 3, 4, 5. We get that. 1, 2, 3, 4, 5. We get that. So that means that our median, because we have 2 numbers in the middle, we're going to find the mean of those 2 numbers. So 22 plus 25 over 2, we have 47 over 2, which is 23.5. Continue to look at the ACT 2017-18 math test, but here we're going to address questions 11 through 15. Question 11. Students studying motion observed a cart rolling at a constant rate along a straight line. The table below gives the distance d feet the cart was from a reference point at 1 second intervals from t equal to 0 seconds to t equal to 5 seconds, and we have a table here. Which of the following equations represents the relationship between d and t? So to look at the relationship, let's look at, this is the independent and this is the dependent. So let's see what's happening in each instance. So we have an increase of 1 at every turn in the independent, and then we have, for the dependent, we have an increase of 6. So what that means is that for every 1 unit change in the independent, the dependent increases by 6. So that lets me know that there is a ratio of the relationship between the independent and dependent is 6t. Now let's look at where we're starting off. So when t is equal to 0, d is 14, so we have a starting point at 14. So you either have 6t plus 14 or 14 plus 6t. 6t plus 14. Okay, now the length of a rectangle with area 54 square centimeters is 9 centimeters. What is the perimeter of the rectangle? So the first thing we're going to do is let's make an attempt at drawing a rectangle. Okay, so we have 9 centimeters here, and then we have, let's call this x for the width. So the area is length multiplied by width. We have 54 square centimeters is 9 centimeters multiplied by the width. So we're going to divide both sides by 9 centimeters to get the width. So 6 centimeters is our width. Now perimeter is length plus breadth multiplied by 2, or length plus width, depends on how you see it. So this is going to be 2 9 plus 6, which is 2 times 15. That's going to give us 30 centimeters. In the figure below, C is the intersection of the line AD and the line BE. If it can be determined, what is the measure of BAC? So this is the angle we're interested in. Now at the point of intersection we have vertical angles, so this is going to be 45 degrees. So now what we have is a situation where we have a triangle. We have a triangle where one of the angles is 45, another angle is 35, and we have a missing angle. So the sum of all angles in a triangle is 180. So we're going to have 35 degrees plus 45 degrees plus, let's call that x, the unknown angle, call it x, plus x equal to 180 degrees. So we have 80 degrees plus x equal to 180 degrees. I'm going to subtract 80 degrees from both sides to get the value of x. So we have x, this is actually not required. So we have x equal to 100 degrees. So Anton drew a circle graph below describing his time spent at school in one day. His teacher said that the number of hours listed were correct, but the central angle measures for the sectors were not correct. What should the central angle measure for the core subject sector be? So let's see. We have how many hours altogether? We got 4 plus 3 plus 1 plus 1. So we have 9 hours altogether. Now here's a trick that we could use because we're dealing with a circle. The sum of all angles in a circle. So we have sum of angles in a circle is going to be equal to 360 degrees. So what we have is that 9 hours will be covering 360 degrees. So 1 hour is going to be equivalent to 40 degrees. So let's see, we're looking at core subjects. Let's pay attention to that. Core subjects, so we have 4 hours for core subjects. It's going to give us 40 degrees times 4, which is 160 degrees. Now another way to look at this is that the fraction of the whole day that is spent on core subjects is 4 hours out of 9, and then we multiply that by 360 as well. So this is 1, this is 40, which is 160 degrees. So it depends on which one you prefer, they get you to the same answer. Number 5, this month Kami sold 70 figurines in 2 sizes. The large figurines sold for $12 each and the small figurines sold for $8 each. The amount of money he received from the sales of the large figurines was equal to the amount he received from the small figurines. How many large figurines did he sell? So let's say we're going to create a system here. First thing we're going to do is let x, let's call that the large figurines, and y is for the small figurines, and total number of figurines is going to be x plus y. And then, so here's our system. We have x plus y equal to 70, and then the cost of the large is going to be 12 times x, and the cost of the small is going to be 8 times x. But what we're told here is that the total amount made from each one is the same. So we have 12x equal to 8y. So now we have this system. The first thing I'm going to do here, or I'll recommend you do, because we're looking for the value of x, which is the large figurines, I'm just going to rewrite this first equation here in terms of x. So I'm just going to say x is equal to 70 minus y. So now that I've done that, I'm going to substitute that value in the second equation. So everywhere I have x, I'm going to replace with 70 minus y. So 12 multiplied by 70 minus y is equal to 8y. So I'm going to distribute this. It's going to give me 840 minus 12y equal to 8y. So we add 12y to both sides of the equation, and we have 840 equal to 20y. So now we divide both sides by 20. So we have y is equal to 42. So that tells me how many small figurines I had. So let's go back and find the value of x. It's going to be 70 minus 42, which is 28 figurines. So we have 28 large figurines. This is the College Board SAT Practice Test 1. We're going to look at the section 3, which is the portion that does not allow the use of a calculator. Question number 1, it says, if x minus 1 divided by 3 is equal to k, and k is equal to 3, what is the value of x? Now, the way to do that is, we rewrite this as x minus 1 over 3 equal to 3. We can rewrite both sides as fractions, and so we have it this way, where we have 3 over 1, and then we can have a cross product here. So that gives us 1 x minus 1 equal to 3 times 3. So x minus 1 equal to 9, and so we add 1 to both sides of the equation. So x equal to 10. So our answer there is D. Number 2, it says I is equal to the square root of -1. What is the sum of 7 plus 3i plus -8 plus 9i? So we just put a 1 out and 1 on the left side of the parenthesis, each of the parentheses, and then let's distribute 1. So we have 7 plus 3i minus 8 plus 9i. Let's group common terms together. We have 7 minus 8 plus 3i plus 9i. And then we have -1 plus 12i. So we have A for our answer. Number 3, we're told on Saturday afternoon, Amand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Amand and Tyrone? So let's look at Amand first. Amand, he sent M text messages per hour, and then he does that for 5 hours. So we have 5 times M, which is 5M. And then we have Tyrone. Tyrone sent P messages every hour for 4 hours. So Tyrone sends 4 times P, which is 4P messages on Saturday. So let's see how many do they send together. So it's going to be 5m plus 4p. 5m plus 4p. Number 4. Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated by the equation P is equal to 108 minus 23D, where P is the number of phones left over and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation? So P is the number of phones. P is the number of phones left. Okay, phones left over. And D is the number of days. Number of days she worked. So what would 108 represent? We can look at it in several ways. First of all, let's try this approach of having P plus 23D equal to 108. So this is the number of phones left over plus the number of days she worked multiplied by 23. So that gives us 108. So that's one approach, and we can see that the number of phones left over plus the number of phones she already repaired gives you how many phones she started the week with. So that is what 108 represents, because if you start the week with 108 phones and you have a subtraction of 23 multiplied by the number of days, then the P here would represent the number of phones you have left over after the work week has been completed. So therefore, 108 represents the value you started off with. Or we can look at it as the y-intercept. If you haven't worked at all, that's the number of phones you have left over. Number 5. So we're going to simplify this. So we have x squared y minus 3y squared plus 5xy squared. This in parentheses, minus, and then we have minus x squared y plus 3xy squared minus 3y squared. To make this easy to distribute, I'm just going to put a 1 out here. So there's also a 1 out here. So we distribute the 1 into this parenthesis. So we have x squared y minus 3y squared plus 5xy squared. Then we have minus 1 distributed into this whole expression. We have plus x squared y minus 3xy squared plus 3y squared. Now let's group common terms. So we have x squared y, we have x squared y here, and then we have another one here, plus x squared y. Then we have minus 3y squared here, 3y squared, and then we have plus 3y squared. And then we have 5xy squared plus 5xy squared, and then minus 3xy squared. So now we have grouped common terms. So this is going to give us 2x squared y minus 3y squared plus 3y squared. That should cross out, give us 0, plus 2xy squared. So the answer is C. So we're going to look at how to solve questions 6 to 10 of the College Board SAT Practice Test 1, and that's going to be the Section 3 math test, the one that requires no calculators. So in this question it states, a pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age A in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So what that means is, so the increase is going to be, for the sake of simplicity, the increase is going to be the slope of that line. So this is, we have h equal to 3a plus 28.6. So 3 is the slope, so this is what our expected increase every year should be. So the slope is 3. But let's see if we can substitute the ages from 2 to 5, or let's say 2 to 5, and see what we get as a difference in the height of the boy. So let's assume that a is equal to 2, so h is going to be 3 times 2 plus 28.6, which is going to give us 34.6. A equal to 3, so h is going to be 3 times 3 plus 28.6, which is going to give us 37.6. A equal to 4, so h is 3 times 4 plus 28.6, which is 40.6. If you look here, as the age increases by 1, the height increases by 3 inches. So we can see that the change is actually 3, it's going to be 3, which is the slope. So this is an understanding of what slope is. Slope measures the estimated increase of a line over a period of time or over some variables. Now we have this equation, and the formula above gives the monthly payment M needed to pay off a loan of P dollars at R%, annual interest over N months. Which of the following gives P in terms of M, R, and N? So let's start with the equation we have. M is equal to R over 1200, 1 plus R over 1200 to the power of N, divided by 1 plus R over 1200 to the power of N minus 1, and then we have a P right here. So what we need to do is, we need to divide both sides, because we want the value of P. We need to divide both sides of the equation by, let's do it this way, we divide both sides by R over 1200, and then 1 plus R over 1200 to the power of N, divided by 1 plus R over 1200 to the power of N minus 1. So what that means to us is that we're just going to flip the numerator and denominator. So this is going to be M multiplied by 1 plus R over 1200 to the power of N minus 1 over R over 1200, 1 plus R over 1200 to the power of N is equal to P, and then we have R over 1200, 1 plus R over 1200 to the power of N, divided by 1 plus r over 1200 to the power of n minus 1 multiplied by 1 plus r over 1200 to the power of n minus 1 over 1 plus r over 1200 to the power of n r over 1200. So you can see this will cross this out, this will cross this out. So this becomes the value of p. So let's see which one has our answer. So we have m multiplied by 1 plus r, okay, so that's going to be b. Number 8, if a over b is equal to 2, so a over b equal to 2, so we can see that a is equal to 2b. So what is the value of 4b over a? So here we can already establish that a is equal to 2b. So we're just going to substitute a with 2b. So 4b divided by 2b. So b crosses out, and then 4 divided by 2 is 2. So that gets us to C. Number 9. What is the solution to the system of equations above? Okay, I'm just going to use the process of substitution. So 3x plus 4y equal to negative 23. 2y minus x equal to negative 19. So I'm just going to I'm going to solve this second equation for x. So I'm going to move x over here. So 2y plus 19 equal to x. So now I'm going to substitute that information into this equation here. So I have 3, 2y plus 19 plus 4y equal to negative 23. So this is going to give us 6y, 3 times 19 plus 57 plus 4y equal to negative 23. Let's group common terms. We have 6y plus 4y plus 57 equal to negative 23. So 10y plus 57 equal to negative 23. So that means that we subtract 57 from both sides. So 10y equal to negative 80. We divide by 10 on both sides, and we have y equal to negative 8. For the sake of this test, one habit to develop is when you get one of the values, let's see if you have only one answer that has that value, or if you have multiple, so you can decide whether you want to go forward, you want to continue. Because remember, in this test, you're trying to work with your time. So y equal to negative 8. Let's see how many instances do we have y equal to negative 8. Just one. So that's our answer. We don't even need to go further. Number 10, for the function g defined above, so we have g of x is equal to ax squared plus 24, okay? A is a constant and g of 4 is equal to 8. So g of 4 equal to 8. That means that a times 4 squared plus 24 equal to 8. So 16a plus 24 is equal to 8. We subtract 24 from both sides. So we have 16a equal to negative 16. So a equal to negative 1. Then we have our equation written this way. G of x equal to negative x squared plus 24. So g of negative 4 is equal to negative 4 squared plus 24, which is negative 16 plus 24, which is equal to 8. Now, let's look at another approach to this question. So we're told that g of 4 is equal to 8. What that means is a of 4 squared plus 24 equal to 8. Now let's look at what g of negative 4 is going to be. G of negative 4 is going to be equal to a of negative 4 squared plus 24. So in this case, we have 16a plus 24 equal to 8. So now here we have 16a plus 24. Just from what we saw here, this is also going to be equal to 8. So if you're really fast on your feet with mathematical problems, this is the approach I would use. But if you're one of those students that just want to see how things flow, then this is the method for you. So we're looking at College Board SAT Practice Test, Section 3, the math section without the calculator. We're going to look at questions 11 through 15. So in this question 11, in the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively. X weeks after July 1st, during last summer, what was the price per pound of beef when it was equal to the price per pound of chicken? Remember that B represents the price per pound of beef and C represents the price per pound of chicken. So we want to find out what was the price per pound of beef when it was equal to the price per pound of chicken. So we want to find out what value of X makes both of them equal. So let's start from there. So we say B equal to C. So 2.35 plus 0.25x is equal to 1.75 plus 0.40x. So let's subtract 1.75 from both sides. We have 0.60 plus 0.25x equal to 0.40x. Now we're going to subtract 0.25x from both sides. So 0.60 is 0.15x. We divide both sides by 0.15. And we have x is equal to 4. So what this means is that after 4 weeks, the price of beef and chicken per pound were the same. So we want to find out what was the price of chicken at that point. So chicken is C is equal to 1.75 plus 0.40x. So it's going to give us 1.75 plus 0.40 times 4. This is 1.75 plus 1.60. So this is 3.35. So that's the answer to that. Number 12. A line in the xy plane passes through the origin and has a slope of 1/7. Which of the following point lies on the line? So it passes through the origin, which is 0, 0, and it has a slope of 1/7, slope equal to 1/7. So we want to find out which of the following point lies on the line. So let's call that point x, y. So let's look at how do we get to the slope. The slope is, let's call that m, is y2 minus y1 over x2 minus x1. So y2 is y minus 0 over x minus 0 is equal to 1 over 7. So this means that 1 over 7 is y over x. So that means that your x value is going to be 7. Your y value is going to be 1. So let's look at the other thing to note is that you can also have multiples of this because we're dealing with 0. Because we're dealing with 0 as the other point, you can have multiples here. So 7, 1, we don't have anything that looks like that. But then if you look at option D, we have 14, 2. So let's 14, 2, 14 and 2. You can see that this point D is a multiple of the point that we're dealing with right here. So because 7 times 2 is 14, 1 times 2 is 2. So let's just kind of test it to see that our thought process is right. So m equal to y2 is 2 minus y1 is 0 over x2 is 14 minus 0. So this is 2 over 14, which is 1 over 7. So this is how you deal with this type of questions. Number 13, if x is equal to if x is greater than 3, which of the following is equivalent to 1 over x plus 2 plus 1 over x plus 3. So let's try to simplify that. That's the first thing I would do in this type of a question. Let's try to simplify it. So 1 over x plus 2 plus 1 over x plus 3. Let's go ahead and simplify the denominator first. So 1 over x plus 2 plus 1 over x plus 3. The least common denominator is going to be x plus 2, x plus 3. And then you divide this through, you get x plus 3 plus x plus 2. So you multiply by 1 in both instances. So we have x plus 3 plus x plus 2 divided by, let's factor this. Looks based on our answers, we're going to factor this. Is going to give us x squared plus 5x plus 6. This is going to give us 2x plus 5 over x squared plus 5x plus 6. But our question is actually 1 over x plus 2 plus 1 over x plus 3. This is going to give us 1 over 2x plus 5 over x squared plus 5x plus 6. This is, when you have this, it means when you have a fraction in the denominator of a fraction and you have a whole number on the top, or what you do here is you have 1 and then you multiply by, then you flip the fraction in the denominator. It's going to be x squared plus 5x plus 6 divided by 2x plus 5. So in your numerator, it doesn't matter if it's a whole number or any variable. As long as you have a term there, you multiply the term in the numerator by the flipped denominator. So this is going to give us x squared plus 5x plus 6 over 2x plus. Number 14. If 3x minus y equal to 12, what is the value of 8 to the power of x over 2 to the power of, 2 to the power of y? So when you see a question like this, the reason why you have this equation over here is because there is some form of a relationship you can create with this to get here. So what we're going to do first is we're going to rewrite 8 and 2 as, we're going to write them as exponents with the same base. So 8 is the same as 2 to the power of 3, and then we have an x over here, and then we have 2 to the power of y. So what this ends up becoming is 2 to the power of 3x divided by 2 to the power of y. Based on exponent laws, this is the same as 2 to the power of 3x minus y. So we're already told that 3x minus y is 12. So this is going to be replaced. We're going to replace 3x minus y with 12. That's how that works. And then the last question in this section, the multiple choice section here. So we have ax squared plus 2 multiplied by bx plus 7 is equal to 15x squared plus cx plus 14 for all values of x, and a plus b equal to 8. What are the possible values of c? Okay, so let's try to create similar expressions. So we have ax plus 2, bx plus 7. Let's distribute this. So we have a bx squared, so that's foiling, we use f, then o plus 7ax I plus 2bx, and then plus 14. So we're told that let's simplify this further. So this is going to be a bx squared plus 7a plus 2b x plus 14. Now this we're going to compare with 15x squared plus 7a plus cx plus 14. So now we have some information that lets us know that a plus b equal to 8, but then based on this, a, b equal to 15. So let's look at the factors of 15. That's probably easier to work with. You have 1 and 15, 3 and 5. So what this means is that a and b would be either 3 or 5. So let's look at 7a plus 2b. So we can say a equal to 3, b equal to 5. We can also have a equal to 5 and b equal to 3. So let's consider the two scenarios. So it's going to be 7 times 3 plus 2 times 5. This is 21 plus 10, which is 31. We also have a scenario where we have 7 times 5 plus 2 times 3, which is 35 plus 6, which is 41. So this is the answer to the question. SAT Practice Test 1, this section 3 that requires no calculators, and questions 16 through 20. So t is greater than 0 and t squared minus 4 equal to 0. What is the value of t? So let's factor this. T squared minus 4 equal to 0. So we have perfect square for t squared and perfect square for 4. So that's going to be t plus 2, t minus 2 equal to 0. So what we have is t plus 2 equal to 0, and another value is t minus 2 equal to 0. So we subtract 2 here, so t equal to negative 2 here. We add 2 on both sides, t equal to positive 2. So here we're told that t is greater than 0, so we select the value of t that is greater than 0, because t minus 2 is less than 0, so this is not a good value for t. So this question here, a summer camp counselor wants to find the length x in feet across a lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1800 feet. So AB is 1800 feet. 1800 feet. So EB is 1400 feet. 1400 feet over here. And we have BD is 700 feet. 700 feet. And CD is 800 feet. 800 feet. So what we can see here is we have a situation of similar triangles. So we have a situation where B, D, C and B, E, A are similar. So what that means is that BD over BE is equal to DC over EA. So this is the ratio we're going to create. So BD is 700 feet. BE is 1400 feet. DC is 800 feet. And then AE is X feet. So let's simplify this. So this is going to be 1/2 equal to 800 feet divided by X feet. So we're going to have a cross product here. So 800 feet times 1 is equal to 800 feet times 2 equal to X feet times 1. So we have 1600 feet equal to X feet. So therefore X is 1600. According to the system of equations above, what is the value of X? So we have X plus Y equal to -9. We have X plus 2Y equal to -25. So we're going to use elimination here. Actually, let's use substitution here. And we're going to find the value of Y from this right here. So Y here is going to be equal to -9 minus X. And then we're going to substitute that into this second equation. So we have X plus 2 multiplied by -9 minus X equal to -25. So X plus 2 times -9 plus 2 times -X equal to -25. So X minus 18 minus 2X equal to negative 25. So let's add 18 to both sides. We have x minus 2x equal to negative 7. So negative x equal to negative 7. We divide both sides by negative 1, and we have x equal to 7. Next question. In a right triangle, one angle measures x degrees where sine x is 4/5. What is cosine of 90 degrees minus x degrees? So let's look at a right triangle. A right triangle, something that looks like it. So we have right triangle, and this angle here is x. We're told that, so we have so, ka, toa. Okay, so sine x degrees is 4/5. So means the opposite side. So this is 4, and hypotenuse for h is 5. So sine x is 4/5. Now we need to find the cosine of 90 minus x degrees, which is going to be this angle right here. So the cosine of 90 minus x degrees is adjacent, which is 4, over hypotenuse, which is 5. So sine x and cosine of 90 minus x will be exactly the same value. Final question, we have a is 5 square root of 2. So 2a is going to be 10 square root of 2, which you get by 5 square root of 2 multiplied by 2. Okay, but here is the way the question is written. So we have 2a is the square root of 2x. So now we need to write that expression 10 square root of 2 without simplifying the radical. So what we're going to end up with is 2a is the same as the square root of 100 multiplied by the square root of 2, which is the square root of 200. How do we get 100? It's actually the square root of 10, which is 10 here, squared, multiplied by the square root of 2. So we have the square root of 200 is 2a. Now, what we see from this is that the square root of 200 is equal to the square root of 2x. So what this means is that 2x is equal to 200. So we divide both sides by 2, and we have x is equal to 100. So that's how you solve this question.
Hello, my name is Lillian Akpe, the co-founder of Mathys Tutors. At Mathys, we are very passionate about helping students achieve their academic goals. We provide tutoring to students from elementary to college level in math, English language arts, science, ACT and SAT. As a result of the pandemic, majority of our courses are exclusively online. Over the years, students that have enrolled in our program have seen improvement in their math skills and in their letter grade, as well as their ACT and SAT scores. This summer, due to the pandemic, we provide free online courses to students and also free resources to students. Our goal is to help 5,000 students by the end of 2020 to improve on their math skills. We believe with your help, we can achieve this goal. Thank you.
campaign is about.
and I'm making
We want
this
to
video
find
today to tell you
5,000
about a
students
wonderful
that fit
opportunity
into
you
any
have
of
to
these
invest in
categories.
yourself and your own
Are you a
future
student
career
struggling
goals
with
by
math
enrolling
today,
in
or a
Matthews
parent
Tutors.
of a
I'm
student
currently a
struggling with
freshman
math today,
student
and
at
you
Columbia
want to
University in
help
the city
build
of New York,
confidence
an
in
Ivy League
your students'
institution
math
where I am
abilities?
studying
The
neuroscience
campaign
and
is for
behavior
you.
on the
Are you a
pre-med track.
student that is
I personally
actually
don't
feeling
believe that I would
comfortable
have the
about math,
ability
but
to
you
call
want to go a
myself
bit
a
higher?
Columbia
You
student
want
had
to
it
build
not
your
been for the
confidence
efforts
level a
of
bit
Matthews
higher?
Tutors
This
offers
campaign is
virtual
for you.
lessons.
Are you
When I
an
was in high
excellent
school, I
student,
struggled with math.
but you
I
need
knew
a
that I struggled
challenge?
with math. Math
This
filled me with
campaign is
fear
for
and I
you. We
wasn't
want to
confident
get
doing it. But after
5,000
just a few
students
sessions with
so
Matthews
comfortable with
Tutors, not
math
only was I
that they've
instilled with the
built a good
confidence to go
foundation
forth in
for
whatever
their
math class
future
I chose to
academic
take,
pursuits.
but I was able to increase
Now,
my ACT
are you
score
interested
by
in joining
almost
us in
10
this
points,
campaign?
helping me
We
earn a
invite
super
you, we
score of
welcome you to join us
35.
in this
With
campaign.
those numbers,
How
I
can
was
you
able
help us with
to
this
get
campaign?
accepted to
Share this
all
video
16
with
colleges
as
I
many
applied
people
to,
as
including,
possible,
but
and
not
we
limited
hope to
to,
see
Cornell
students sign
University,
up because
Georgetown University,
we want to
Tulane
see every
University,
student
Duke University, and the
become
college I
comfortable
currently
enough
attend,
with math
Columbia
that they
University.
conquer their
Matthews
fear
Tutors
of
is
math.
going to do
Please
everything
join
they can
us,
to help you.
and I'm
That's what they
sure
did
you
for
will
me. Not
enjoy
only
the
are they gonna
result
help you be
of
a better
this
student, they're
campaign.
going to continuously
Thank
check
you.
in on you. I know that I personally received a
Hello,
lot of
my name
messages
is
of
Lillian
support from
Akpe,
them
the
during my
co-founder
first
of
semester
Matthews
of college, which
Tutors.
was one of the
At
hardest
Matthews,
semesters
we are
I've
very
ever
passionate
experienced
about
as a
helping
student.
students achieve
Matthews
their
made sure that
academic
I had the
goals.
confidence
We
to go
provide
forth and pursue
tutoring
my
to
own
students
academic
from
goals,
elementary
but
to
they
college
also
level
helped me increase
in
the
math,
numbers too, so that
English
I could
language
get where I
arts,
wanted to be.
science,
And I know that they can do the
ACT
same
and
thing for you if you
SAT.
give them a chance. Thank you.
As a result of the pandemic, majority of our courses are exclusively online. Over the years, students that have enrolled in our
Hello, Nduka here from Matthews Tutors. I'm here to announce a special campaign that we're about to kick off. It's the 5,000 Students for Math. Here's what the campaign is about. We want to find... Hello, Nduka here from Matthews Tutors. I'm here to announce a special campaign that we're about to kick off. It's the 5,000 Students for Math. Here's what the campaign is about. We want to find 5,000 students that fit into any of these categories. Are you a student struggling with math today, or a parent of a student struggling with math today, and you want to help build confidence in your students' math abilities? The campaign is for you. Are you a student that is actually feeling comfortable about math, but you want to go a bit higher? You want to build your confidence level a bit higher? This campaign is for you. Are you an excellent student, but you need a challenge? This campaign is for you. We want to get 5,000 students so comfortable with math that they've built a good foundation for their future academic pursuits. Now, are you interested in joining us in this campaign? We invite you, we welcome you to join us in this campaign. How can you help us with this campaign? Share this video with as many people as possible, and we hope to see students sign up because we want to see every student become comfortable enough with math that they conquer their fear of math. Please join us, and I'm sure you will enjoy the result of this campaign. Thank you. Alright, in this lesson, we're going to look at how to solve word problems that have to do with comparing fractions. We're going to start by outlining the steps that are ideal when you're trying to solve word problems that have to do with comparing fractions. And then, in usual fashion, we will walk through some examples together following those same steps. Now, when you have word problems that have to do with comparing fractions, you have to examine a few things. One of the things you want to do is, if you have mixed numbers in the word problem, you always want to first go ahead and convert the mixed number to improper fractions. And if you have fractions that have different denominators, you want to get the least common multiple of each of those denominators, and then create equivalent fractions for each of those improper fractions, or it could also be proper fractions in cases where it's proper fractions, but you want to create new fractions with common denominators so you can use the numerators to compare the value of those fractions. So now we're going to look at some examples together. In a reading test, the students are expected to answer 3/4 of the questions correctly to earn a passing grade? Thomas answered 5/6 of the questions correctly. Did he earn a passing grade? So we have 3/4 and 5/6. So we have 3/4, 5/6. So the first thing we're going to do here is to find out what the least common multiple of 4 and 6 is going to be. 4 is 2 squared, 6 is 2 multiplied by 3, and so the LCM is going to be 2 squared multiplied by 3, which is going to give us 4 multiplied by 3, and that's 12. So the next thing we're going to do is to convert each of these fractions to an equivalent fraction with a denominator of 12. So 3/4 now becomes, we're going to multiply 4 by 3 to get 12, and we multiply 3 by 3 to get 9. So you have 9/12. And then 5/6, we need to multiply 6 by 2 to get 12, and then 5 by 2, we have 10/12. So what we're saying here is that you need 9/12 to pass, but Thomas got 10/12. So therefore, Thomas actually passed the test. So Thomas earns a passing grade. So Thomas earns passing grade. So he's going to earn a passing grade. The next example, Maria, John, Brianna, and Lucas competed in a car race. If their times are 1.5 hours, 6/5 hour, 7/6 hour, and 1/3 hours, accordingly, arrange the driver's completion time in increasing order. So we have, first thing we're going to do is convert every mixed number to an improper fraction. So 1.5 is going to be 1 multiplied by 2 plus 1 over 2, which is going to be 2 plus 1 over 2, and that's going to give us 3/2. The second one is 1/3. So 1/3 is going to be 1 multiplied by 4 plus 3/4, which is going to be 4 plus 3/4, and now we have 7/4. The next thing we're going to do now is we're going to find the LCM of all the denominators. So we have 2, 4, 5, 6, and then we need to find the LCM. So it's 2 to the power of 1, 4 is 2 squared, 5 is 5 to the power of 1, 6 is 2 multiplied by 3, so 2 to the power of 1, 3 to the power of 1. So the LCM is going to be 2 squared multiplied by 3 multiplied by 5, which is going to give us 4 times 3 times 5, which is 12 times 5, and that's going to give us 60. So now our fractions are 3/2, and then we have 6/5, we have 7/6, and we have 7/4. So what we're going to do now is we're going to convert this to equivalent fractions with a denominator of 60. So we're going to multiply 2 by 30, and then 3 also by 30. This is going to give us 90/60. Then 6/5, we're going to multiply 5 by 12 and 6 by 12. So that's going to give us 72/60. And then 7/6, we're going to multiply 6 by 10, and then 7 by 10, we're going to get 70/60. And then we're going to multiply 4 by 15, 7 by 15. We're going to get 60 in the denominator, 105 in the numerator. So our fractions are now 90/60, 72/60, 70/60, and then 105 over 60. So here we're trying to arrange the driver's completion time in increasing order. So that is from the smallest to the largest. So we have 70 over 60. Then we have 72 over 60. We have 90 over 60. And then we have 105 over 60. So now let's replace them with the original fractions. So 70 over 60 is 7 over 6. 72 over 60 is 6 over 5. 90 over 60 is 1.5. And then 105 over 60 is 1/3. So now this is arranging the completion time in increasing order. So now, who was the fastest driver? The fastest driver is the driver that completed in the shortest amount of time. Fastest driver is the one that drives 7 over 6 hours, which ends up being Brianna, because Maria has this time right here, John has this time right here, Brianna has this time right here, and Lucas has this time. So fastest driver is Brianna. Next example, Milton and Dharma went to pick grapes in a vineyard. The grapes Milton picked weighed, that's wrong. So it's weighed 29 over 4 pounds, and those Dharma picked weighed 7 1/3 pounds. First thing we're going to do here is convert 7 1/3 to an improper fraction. So 7 1 over 3 is going to be 7 multiplied by 3 plus 1 over 3, which is 21 plus 1 over 3. That's going to give us 22 over 3. The next thing we're going to do is to find the LCM of 3 and 4. So we got 3, we got 4, LCM. 3 is 3 to the power of 1, 4 is 2 squared. LCM is 2 squared multiplied by 3, which is 4 multiplied by 3 gives us 12. So now we have 22 over 3, and then we have 29 over 4. So let's convert 22 over 3 to a fraction with a denominator of 12. So 22 over 3 is equal to, we multiply 3 by 4 until we multiply 22 by 4. That's going to give us 88 over 12. And then 29 over 4, we're going to convert this to a fraction with a denominator of 12. So we multiply 4 by 3, we multiply 29 by 3. This is going to give us 87 over 12. So who picked more grapes? So you can see that 88 over 12 is greater than 87 over 12. So whoever picked this, so 88 over 12 corresponds with 7 1/3 pounds. So 7 1/3 pounds is greater than 29 over 4. So now, what we're going to say here is that Dharma picked more grapes. And then the final example, Riley wants to create a vegetable garden in his yard. He needs 23 over 4 feet of wood to create this garden. If he finds 5 2/5 feet of wood in his storage, does he have enough wood to create the vegetable garden? The first thing we're going to do here is convert 5 2 over 5 to an improper fraction. So we have 5 2 over 5 is 5 multiplied by 5 plus 2 over 5, which is equal to 25 plus 2 over 5, and we now have 27 over 5. Next thing we're going to do is find the LCM of 4 and 5. 4 is 2 squared, 5 is 5 to the power of 1, so LCM is going to be 2 squared multiplied by 5, which is 4 multiplied by 5, and that's going to give us 20. So now we have 23 over 4 here as our fraction, and then we have 27 over 5. So we're going to rewrite each of these fractions as a new fraction with a denominator of 20. So we're going to multiply 4 by 5 to get 20. So we multiply 23 also by 5. This is going to give us 115 over 20. And here we're going to also multiply 5 by 4 so we can get 20. And then we multiply 27 by 4. This is going to give us 108 over 20. So how much wood does he need? He needs 115 over 20 feet, but he has 108 over 20 feet. So therefore, Riley does not have enough wood. So that's what this means. He needs to get more wood if he's able to create the vegetable garden. Okay, we're going to look at patterns with whole numbers, and we're looking at patterns that are created by multiplication or division. To do this, we'll first start by outlining the steps that are required to complete multiplication or division patterns, and that we're going to use those steps to also help solve some questions together. Now, what are these steps? The first step you want to do is to divide the second term by the first term in the pattern, and then you're going to multiply that value by the second term to give you the third term, and then you do that until you have completed the pattern that has been provided. Now we're going to look at some examples. So we have this pattern here, 2, 6, 18, 54. The first thing we're doing here is we divide the second term, 6, by the first term, which is 2. It's going to give us 3. Now we're going to multiply 6 by 3. That's going to give us 18. We multiply 18 by 3. That should give us 54. Now we're going to multiply 54 by 3. So let's do this. 54 by 3. So 54 multiplied by 3. It's going to give us 12. We put 1 here, 16. This is 162. 162 multiplied by 3. We have 6. 6 times 3, 18. We have 1 multiplied by 3. 3 plus 1, 4. So we have 162. 162 multiplied by 3 is going to give us 486. Now we have 486 multiplied by 3. So let's go ahead and walk through that. 486 multiplied by 3. 6 times 3 have 18. We put 8, we carry 1 up here. 8 times 3, 24 plus 1, we have 25. We put a 5 here, bring up a 2. 4 multiplied by 3, 12 times plus 2, we have 14. So this is going to give us 1458. So our terms are 162, 486, and then 1458. Next example, we're going to divide the second term by the first term. So 128 divided by 256. This is going to give us, let's see, what's the best way to go about this? We can keep dividing. Let's divide by 8 first. When we divide by 8, we have 16 over 32. Let's divide again by 8. We divide by 8, we're left with 2 over 4. Now we can divide by 2. This is going to give us 1 over 2. So now what this means to us is that we're going to keep multiplying by 1 over 2. Okay, so what that means is 128 multiplied by 1 over 2 is going to give us 64. 64 multiplied by 1 over 2 is the same as dividing 64 by 2. It's going to give us 32. Now 32 multiplied by 1 over 2. So let's go ahead and do our division. 32 divided by 2. We have 1, 2, 20. 1, 2, 12 divided by 2. We have 6 multiplied by 2, 12. We have a remainder of 0. It's going to give us 16. 16 multiplied by 1 over 2. That's going to give us 8. 8 multiplied by 1 over 2 is going to give us 4. So after 32, we have 16, 8, and 4. Next example, find the missing numbers in the pattern below. So we have 12 divided by 3. It's going to give us 4. 12 multiplied by 4 is 48. 48 multiplied by 4. Let's go ahead and walk through that together. 48 multiplied by 4. 8 multiplied by 4 is 32. We have a 2 here. We bring a 3. 4 multiplied by 4. 16 plus 3. We have 19. So we have 192. 192 multiplied by 4. So 192 multiplied by 4. 2 multiplied by 4, 8. 9 multiplied by 4, 36. So we have 6 here. We bring up a 3. 1 multiplied by 4, 4 plus 3, 7. So we have 768. 768 multiplied by 4. So we multiply by 4 right here. 8 multiplied by 4 is 32. We have 2 here. We carry 3 up here. 6 multiplied by 4, 24 plus 3, 27. We have 7, we'll bring up a 2. 7 multiplied by 4, 28 plus 2, we have 30. So this is going to give us 3072. So after 48, we have 192. We have 768. And then we have 3072. Now our final example together. We have to divide the second term by the first term. So 81 divided by 243. We can divide both of them by 9, and we have 9 over 27. We divide again by 9. We have 1 over 3. So now we're going to multiply 81 by 1 over 3. This is going to give us 27. 27 multiplied by 1 over 3, we're going to get 9. 9 multiplied by 1 over 3, we're going to get 3. And 3 multiplied by 1 over 3, we're going to get 1. So one thing I want you to look at as you're going through this lesson is when you see me doing a multiplication by a fraction, it's actually the same as you can multiply across. So that's going to be 81 divided by 3. Because if you don't have a denominator, you can safely assume that to be 1. So it's 81 divided by 3, 27 divided by 3, 9 divided by 3, 3 divided by 3. That's why we have these values. In this lesson, we're going to learn how to divide fractions by whole numbers. How are we going to go about it? We're going to examine the steps. We're going to look at the steps that we need to follow to divide fractions by whole numbers. And then, in our usual fashion, we are going to walk through some examples together following those same steps so that you can do them on your own independently. So what are these steps? The first thing we need to do is to write the whole number as a fraction with 1 as its denominator. This is most likely going to be, or rather, this is definitely going to be an improper fraction. So what we're saying here is if I had 3 as my whole number. I'm going to now replace it with 3 over 1. So 1 has to be the denominator. Now we're going to flip the numerator and the denominator on the fraction or of the fraction on the right side of the division symbol. We're going to multiply across the numerators, multiply across the denominators, and then simplify the result. Now let's look at some examples together. Evaluate 5 over 6 divided by 4. So what we're saying here is 5 over 6 divided by, we're going to make 4. Let's do it this way. The first step here is actually to write 4 as 4 over 1. Now we're going to replace 4 with 4 over 1. And now what we need to do is remember, on the left side of the division symbol, we stay the same. On the right side, we flip positions and then we change the sign to a multiplication. And now we have multiplication across 5 multiplied by 1 divided by 6 multiplied by 4. And then we have 5 over 24. And that's the simplest form. Next example, we go ahead and change 3 to an improper fraction with 1 as its denominator. And now we have 4 over 9 divided by 3 over 1. And now, using our practice for division, we leave the number or the fraction on the left side alone. The fraction on the right hand side, we flip positions, change the sign to a multiplication. Now we can multiply across the numerator and multiply across the denominator. 4 multiplied by 1, we have 4. 9 multiplied by 3, we have 27. That's the simplest form. 7 over 8 divided by 2. Let's write 2 as an improper fraction with 1 as its denominator. That gives us 2 over 1. So now we have 7 over 8 divided by 2 over 1. And now we leave the fraction to the left hand side alone. The fraction to the right hand side, we flip. It becomes 1 over 2. Change the sign to a multiplication. Then we can now multiply across 7 multiplied by 1 over 8 multiplied by 2. 7 multiplied by 1, we have 7. 8 multiplied by 2, we have 16. That's the simplest form. Now our final example, evaluate 4 over 5 divided by 2. So let's go ahead and write 2 as an improper fraction with 1 as its denominator. Gives us 2 over 1. So now we have 4 over 5 divided by 2 over 1. Now the left side of the fraction to the left side of the division symbol stays exactly the same. The fraction to the right hand side switches position. So we're flipping it, so it becomes 1 over 2. We change the sign to a multiplication symbol. And then we can multiply across 4 multiplied by 1 over 5 multiplied by 2. Now we have some common values. So 2 divided by 2, we have 1. 4 divided by 2, we have 2. So now we can multiply across again. We have 2 multiplied by 1 over 5 multiplied by 1. This is going to give us 2 over 5, and that's the simplest form. Now we're going to be looking at how to divide mixed numbers. To do this, we're going to examine the steps we follow in dividing mixed numbers, and then, as we usually do, we're going to walk through some examples together following those steps. Now, the first thing we're going to do when we're dividing mixed numbers is we're going to convert each of the mixed numbers to improper fractions. And then when you're done with that, you're going to flip the numerator and denominator on the fraction on the right side of the division symbol, and then change that division symbol to a multiplication. And then we're going to multiply the numerators together. So we multiply across. We multiply the denominators together, multiply across, and then we reduce the fraction to its simplest form if possible. And if you want, you can now multiply it by 2 plus 1 over 2, which is 4 plus 1 over 2, which gives us 5 over 2. So now our problem is going to be written this way. We're going to write 20 divided by 3 divided by 5 over 2. So now we're saying here that we're going to flip the fraction on the right hand side. So that's going to be 2 over 5. And then we can change the sign to a multiplication. So we can multiply across 20 multiplied by 2 divided by 3 multiplied by 5. Now we can try to simplify. So we have 5 divided by 5, we have 1, and then 20 divided by 5, we have 4. So this is going to give us 4 times 2 over 3, which is going to give us 8 over 3. If you want to take the extra step, you can convert that back to a mixed fraction or a mixed number. 8, 3, you have 2 times 3, 6, we have a remainder of 2. We have a remainder of 2, so this is also the same as 2 2/3. Let's try the second example. Our next example is 8 1 over 7 divided by 1 1 over 6. So we have 8 1 over 7 is the same as 8 multiplied by 7 plus 1 over 7, which is going to give us 56 plus 1 over 7, which is 57 over 7. And then 1 1 over 6 is 1 multiplied by 6 plus 1 over 6. Is going to give us 6 plus 1 over 6, which is 7 over 6. So now what we have is 57 over 7 divided by 7 over 6. So now what we're going to do is 57 over 7. The fraction on the right hand side, we're going to flip it 6 over 7 and change this to multiplication. So we now have 57 multiplied by 6. 7 multiplied by 6 is going to give us 42. We have 2. We bring 4 up here. 5 multiplied by 6 is 30 plus 4, 34. So this is going to give us 342 over 49. And the reason why we have that is because we multiply across in the numerator and the denominator. So now you have this option, or you can convert back to a mixed number. So let's go ahead and try this. 342 divided by 49. If you do this, it's probably going to give you 6. And then 6 multiplied by 49 is going to give you 294. And then 12 minus 4 is 8. 13 minus 9. 13 minus 9 is 4. So you're going to end up with 6 whole number 48 over 49. One more example. 7 1 over 5 divided by 2 4 over 7. The first thing we're going to do is to convert each of them into an improper fraction. So let's start with 7 1 over 5. 7 1 over 5 is going to be 7 times 5 plus 1 over 5, which is going to give us 35 plus 1 over 5, which is 36 over 5. So 2 4 over 7 is 14 plus 4 over 7, which is 18 over 7. So now what we have here is 36 over 5 divided by 18 over 7. And so what we're saying here is we lift the one on the left hand side, the one to the right of the division sign, we're going to flip. So it's going to be 7 over 18, and then we change the sign to multiplication. So this is going to give us 36 times 7 over 5 times 18. So we're going to go ahead and do some division here. So this is we can divide by 3 here, we get 6. Divide by 3 here, we get 12. We can divide by 6 here, we get 1. Divide by 6, we get 2. So now we're left with 2 times 7 over 5, which is going to give us 14 over 5. That's one way to leave your answer, or you can convert back to a mixed number. 14 over 5, we have 2 times. 2 times 5 is 10. We subtract, we're left with 4. So this is going to give us 2, 4 over 5. So our final example, 9 1 over 3 divided by 3.5. So first step is to convert each of them into an improper fraction. So 9 1 over 3 is 9 multiplied by 3 plus 1 over 3. 9 multiplied by 3 is 27 plus 1 over 3, which is 28 over 3. And then 3.5 is going to be 3 multiplied by 2 plus 1 over 2, which is 6 plus 1 over 2. It's going to give us 7 over 2. So now what we have here is 28 over 3 divided by 7 over 2. Now we're going to leave the fraction on the left hand side, and then the one on the right hand side we're going to flip to 2 over 7 and change the sign to a multiplication. So now we have 28 multiplied by 2 over 3 multiplied by 7. So now we can simplify. So we have 7 divided by 7, 1. 28 divided by 7, we have 4. So this is going to give us 4 times 2 over 3 times 1, which is 8 over 3. Or you can convert to a mixed fraction, mixed number. 8, 3, we have 2. 2 times 3 is 6. Subtract, we have a remainder of 2, which is also the same as 2 over 3. We are going to be looking at direct variation. To do this, we're going to explain what direct variation is. We're going to also examine the steps that we use to solve direct variation problems. And then we're going to also solve direct variation problems, including word problems. So direct variation is just a way to express a relationship between two quantities. We represent it as x varies directly as y, or you can also say y varies directly as x. And we represent it with y equal to kx, where k is the constant of variation. And the important part about direct variation here is that as one quantity increases, the other quantity also increases. Now you may ask, how do I go about solving direct variation problems? The first thing you want to always do is write it as an equation. Here it shows that y varies directly as x, with k being a constant of variation. The next thing we're going to do after that is to find the value of the constant of variation, or the constant of proportionality. And then when you find that value, you can rewrite the equation with the value of k, which is our constant that we found in the previous step. And then we will use the equation to find any missing information. Let's go look at some examples, and then you can see how to apply this. So we're given here that y varies directly as x. So y varies directly as x. We want to find the constant of variation if y is 24 and x is 3. So y is 24 and then x is 3, so we have k multiplied by 3. So we want to find the value of k, which is our constant of variation. Some call it the constant of proportionality. That also works. So we can divide both sides by 3. And then we can see that 8 is equal to k. So our equation now becomes y is equal to 8x. And this is what you want to aim for when you're trying to deal with direct variation. Suppose y varies directly as x and y is equal to 30 when x equal to 6. What is the value of y when x equal to 100? So our first step is going to be y equal to kx, and then y is 30, and then we have k multiplied x is 6. So we're going to divide both sides by 6, and then we have k equal to 5. So now our equation is going to be y equal to 5k. So now it's asking what is the value of y when x equal to 100. Sorry, this is not 5k, it should be 5x because k is 5. Y is equal to 5x. Now we want to find the value of y when x is 100. Y is equal to 5 multiplied by 100. So y is equal to 500. So that is the value of y when x is 100. Next equation. If c varies directly as the square root of d and c equal to 6 when d is equal to 256, find c when d is 625. Okay, so let's go ahead and write the equation. So c varies directly as the square root of d, so it's going to be k multiplied by the square root of d. Now c is equal to 6. We need to find the value of k when d is equal to 256. So c is equal to k multiplied by 16, and then we divide both sides by 16. So k is equal to 6. Hello, Nduka here from Math East Tutors. I'm here to announce a special campaign that we're about to kick off. It's the 5,000 Students for Math. Here's what the campaign is about. We want to find 5,000 students that fit into any of these categories. Are you a student struggling with math today, or a parent of a student struggling with math today, and you want to help build confidence? I will be showing you how to multiply binomial algebraic expressions using the distributive property. I'm going to explain to you what binomial expressions are and how to use the distributive property, and then we're going to walk through some examples using the distributive property to multiply binomial expressions together. So a binomial expression is one that has two unique terms. Here you can see x plus 1 as an example. I can also say p minus q as another example, has two unique terms. Now, when you're trying to multiply algebraic expressions using the distributive property, you have to make one of the expressions the constant expression, and then you will distribute each term in the constant expression into the second expression. Then we're going to combine common or like terms and simplify. Now let's look at some examples. So use the distributive property to simplify the expression below. So I'm going to make x minus 2 is going to be our constant term. So here's how it works. So I'm going to say x multiplied by 2x plus 3. Then I take minus 2 multiplied by 2x plus 3. Now we simplify. So I'm going to distribute x into each of these terms, and then I'll distribute minus 2 into each of the terms here as well. So I have 2x squared plus 3x minus 4x minus 6. So now I have 2x squared, 3x minus 4x, that's going to be minus x, and then minus 6. Next example, x plus 1 multiplied by 3x plus 5. I'm going to make x plus 1 my constant term. And so here we go. We have x, we distribute that into 3x plus 5 plus 1, distribute that into 3x plus 5. So now let's go ahead and perform the distribution. So that's going to be 3x squared plus 5x plus 3x plus 5. So that's going to give us 3x squared plus 5x plus 3x is 8x plus 5. Another example. Let's make 4x minus 3 our constant term. So we have 4x, 2x plus 5 minus 3, 2x plus 5. So 4x multiplied by 2x, we have 8x squared plus 20x minus 6x minus 15. So now we have 8x squared, 20x minus 6x plus 14x minus 15. In this case, I will make 4x minus 3 a constant term. So we have 4x multiplied by 6x minus 1 minus 3, 6x minus 1. So let's go ahead and distribute. We have 24x squared minus 4x minus 18x plus 3. So we have 24x squared minus 4x minus 18x, that's minus 22x plus 3. Final example. 3x plus 2 multiplied by 3x minus 2. So let's go ahead and make 3x plus 2 our constant term. So we have 3x minus 2 plus 2, 3x minus 2. So we have 9x squared minus 6x plus 6x minus 4. So we have 9x squared plus 6x minus 6x. That's going to be 0 minus 4. So 0 minus 4 is minus 4. So we have 9x squared minus 4. Now let's take a look at prime and composite numbers. In this session, we'll look at identifying prime numbers, identifying composite numbers, and we will make an attempt to answer the question, is 1 a prime number? Now we start off with prime numbers. Prime numbers only have two factors, 1 and itself. An example of a prime number is 2. So 2 has two factors, 1 and 2. Let's look at 3. We have 1 and 3. Let's look at 5. We have 1 and 5. Let's look at 7. We have 1 and 7. Now, we can see one thing we'll know here is 2 is going to be the only even number that is prime, and every other prime number is going to be an odd number. Now, let's look at, we have 3, 5, 7. Let's look at 9. 9, for example, has 1, it has 3, it also has 9. So because this has more than two factors, this is considered not prime. So now when you have a situation where a number has more than two factors, we introduce the concept called composite numbers. So a composite number is a number that has more than 2 factors. As we saw with 9 earlier, we can see 1, 3, and 9. So you have 1, 2, 3 factors. So that means 9 is a composite number. What about 15? So we have 1, 3, 5, and 15. So 15 is also a composite number. Let's try a few more. Let's look at 18. We have 1, 2, 3, 6, 9, and 18. So this is definitely a composite number. Now we're going to try to answer a question that plagues a lot of students. Is 1 a prime number? Quite frankly, 1 used to be considered a prime number, but when you follow the definition of a prime number has 2 factors. Let's look at the number 1. How many factors can we have? It has only 1 factor because 1 times 1 is 1. So it has only 1 factor. So because it has 1 factor, this means 1 is not a prime number. 1 is not a prime number, and that's the only reason, because it has 1 factor. It does not satisfy the test for a prime number. We're going to take a look at factor and factor trees. We're going to look at understanding factors, understanding prime factors, and developing factor trees. Now, let's start off with a factor. So, a factor or a number has factors if you can find the numbers that you multiply together to get that number. So, what that means here is if I had a number like 6, 6 has factors. The possible factors are 1 and 6, 2 and 3. So what you can see here is that 1 and 6 are factors of 6, 2 and 3 are factors of 6. So if you wanted to list the factors of 6, you have 1, 2, 3, and 6. So that means that 1, 2, 3, and 6 are factors of 6. If I wanted to look at something like 12, I have 1 and 12, 2 and 6, 3 and 4. So the factors of 12 are 1, 2, 3, and 6. So that's how the concept of factors works. Now let's look at prime factors. Remember that a prime number is a number that has only 2 factors, 1 and itself. And also remember that 1, it's not a prime factor. It's not a prime number. So in the case of prime factors, the factors of the number must be prime numbers. So let's look at the examples we used earlier. We had 6, and we agreed that our factors were 1, 2, 3, and 6. So if you look at this is not a prime number, so it cannot qualify as a prime factor. Now you look at 2 is a prime number, it's considered a prime factor. 3 is a prime number, it's considered a prime factor. What about 6? 6, because it has more than 2 factors, it cannot be considered a prime factor. So in this case, the prime factors here, I'll denote as PF, will be 2 and 3. What about 12? From what we saw earlier, we have 1, 2, 3, 4, 6, and 12. Now, when we look at the prime numbers here among the factors, this isn't one of them. This isn't, this is not a prime number, and this is also not a prime number. So you can see that 2 and 3 are the only prime factors here, and so our goal would be to write 12 as a product of its prime factors, which is 2 and 3. And that is where our next content comes in, factor trees. So what we're going to do with factor trees is try to write, we're going to create a tree-like structure that will show a number broken into its prime factors. Let's start off with 12. So this is what we're going to do. We have 12. We're going to create a tree-like structure. So let's start off with the prime factor. We start off with 2. If I divide 12 by 2, I have 6. Now, if I divide 6 by 2, I have 3. So that means here that 12 is 2 times 2 times 3. You can see that each of these numbers here is a prime number, so therefore they could qualify as prime factors. Another way to write this is 2 occurs twice, which is 2 squared times 3. Now, let's look at another example. Let's try 48. So we're going to create our factor tree here, 2, and then we have 24. So 2 times 24 is 48. Now we break this up again, 2 and 12. We break this up again, 2 and 6. We break this up again. We have 2 and 3. So what we see here is 48 is 2 times 2 times 2 times 2 times 3. And so we see 1, 2, 3, 4. So 2 appears 4 times 3. Let's look at some more examples. Let's look at a number like 45. So here, the smallest prime factor here is 3. We have 15, and then we have 3 and 5. So 45 is the same as 3 times 3 times 5. This is going to give us 3 occurs twice times 5. Let's try one more example here. Let's try 63. So 3 and 21, 3 and 7. So you can see here, an important thing to note here is that in this factor tree, all the factors right here are prime numbers. So what we have here is 63 equal to 3 times 3 times 7, which is 3 appears twice times 7. Let's take a look at some 3-digit numbers. Let's look at something like 168. So 2, we have 84. Divide by 2, we have 42. Here we got 2 and 21, and then we have 3 and 7. So therefore, 168 is equal to 2 times 2 times 2 times 3 times 7. We can rewrite this as 2 occurring 3 times, which is 2 to the 3rd power, times 3 times 7. We will be learning how to multiply by 3-digit numbers. We're going to multiply without carrying and multiply with carrying. So to multiply without carrying, you want to first arrange the numbers vertically, and then your multiplication starts from, you're going to multiply the numbers on the top row by the number on the bottom row, starting from the right hand side, and then you keep moving to the left hand side until you've consumed all the digits, or you have multiplied by all the digits. So let me just show you what all of this means. So we have 432 multiplied by 312. So we have 432, then 312. So we arrange them vertically and we multiply. So we're going to start from the right hand side. So let's look at the numbers we're going to multiply by. We start by multiplying by 2. So we have 2 multiplied by 2, we have 4. 3 multiplied by 2, we have 6. And 4 multiplied by 2, we have 8. Now we switch over to this number here. An important thing to note here is that we have to make sure that when we multiply by 1, because 1 is in the tens place, we're going to start this off by putting a 0 right here. Now 2 multiplied by 1, we have 2. 3 multiplied by 1, we have 3. 4 multiplied by 1, we have 4. Now we switch over to the hundreds position. So with that in mind, we're going to place zeros in the ones position and a 0 in the tens position. Now 2 multiplied by 3, we have 6. 3 multiplied by 3, we have 9. 4 multiplied by 3, we have 12. So now what we're going to do is, now that we've arranged these numbers vertically, we're going to place in zeros. We're going to replace every empty spot with a 0. So we have a 0 here, we have a 0 here, and a 0 here. Then we have a 0 here and a 0 here. And then we add these numbers together. 4 plus 0 plus 0, we have 4. 6 plus 2 plus 0, we have 8. 8 plus 3 plus 6, 8 plus 3 is 11, plus 6 we have 17. So we have 7 here and we carry 1 up here. 1 plus 4, 5, plus 9, 14. We have 4 here and we carry 1 up here. 1 plus 2, we have 3, and then 0 plus 0 plus 1, we have 1. So next example, we have 412 multiplied by 241. So we're going to start from the right hand side on the multiplier. So 2 multiplied by 1, we have 2. 1 multiplied by 1, we have 1. 4 multiplied by 1, we have 4. Now we're going to go over to the number in the tens position, but then we need to remember to start in the ones place. We put a 0 in there. So 2 multiplied by 4, we have 8. 1 multiplied by 4, we have 4. And then 4 multiplied by 4, we have 16. Now we switch over to the hundreds position. We're going to multiply. We're going to first add zeros in the ones place, tens place. Now we have 2 multiplied by 2, we have 4 there. 1 multiplied by 2, we have 2. 4 multiplied by 2, we have 8. Now we fill all the empty spots with zeros, and then we add the numbers together. 2 plus 0 plus 0, we have 2. 1 plus 8 plus 0, we have 9. 4 plus 4, we have 8, plus 4, we have 12. So we have a 2 here, and we bring up a 1. 1 plus 6, 7, plus 2, we have 9. 0 plus 1, we have 1, plus 8, we have 9. Now we're going to multiply a 4-digit number by 3-digit number. So we have here 6, 1, 2, 1, and then 4, 23, and we're multiplying these numbers. So we're going to start from the right hand side here, and so we have 1 multiplied by 3 gives us a 3, 2 multiplied by 3 gives us a 6, 1 multiplied by 3 is 3, and then 6 multiplied by 3, we have 18. Now we're going to the tens position, and with that in mind, we have to add a 0 to the ones position. 1 multiplied by 2, we have a 2. 2 multiplied by 2, we have 4. 1 multiplied by 2, we have 2. 6 multiplied by 2, we have 12. We have 2 here and 1 here. And then, finally, we go to, on the multiplier, the hundreds position. So that means we're going to replace, we're going to have 0 in the ones position, 0 in the tens position, and then we can now start multiplying. 1 multiplied by 4, we have 4. 2 multiplied by 4, we have 8. 1 multiplied by 4, we have 4. 6 multiplied by 4, we have 24. We have 4 here and a 2. So we have a 0 here, and then we replace all the empty spots with zeros. So let's count number of digits. You should have 7 digits on each row. 1, 2, 3, 4, 5, 6, 7. 7 on each row. Okay, now we can add the numbers together. So 3 plus 0 gives us a 3. 6 plus 2 plus 0, we have 8 plus 0, that's 8. 3 plus 4, 7. Plus 4, we have 11. So we write 1 down here and we bring 1 up here. 1 plus 8, 9, plus 2, 11, plus 8, 19. So we have a 9 here and we carry up a 1. 1 plus 1, 2, plus 2, 4, plus 4, we have 8. 0 plus 1, we have 1. Plus 4, we have 5. 0 plus 0, 0 plus 2, we have 2. Now, final example that does not require carrying in your multiplication. We have 4, 0, 2, 2, and then we have 3, 4, 2. Now we multiply this together. We're going to start from the multiplier. We're going to start from the right hand side. So 2 multiplied by 2, we have a 4. 2 multiplied by 2, we have a 4. 0 multiplied by 2, we have a 0. 4 multiplied by 2, we have 8. Now we switch over to the tens position, and then we're going to first start by adding a 0 in the ones position. Now we have 2 multiplied by 4 gives us 8. 2 multiplied by 4 gives us 8. 0 multiplied by 4 gives us a 0. 4 multiplied by 4 will give us a 16. Okay, now we switch over to the hundreds position, and we have, so we have to start by putting zeros in the ones position and tens position. So 2 multiplied by 3, we have 6. 2 multiplied by 3, we have 6. 0 multiplied by 3, we have 0. And then 4 multiplied by 3, we have 12, 2, 1. Now we're going to replace all the empty spots with zeros. 0 here, 0 here. We have a 0 and a 0. So we have 7 digits on each row. Now we add this together. 4 plus 0 plus 0, that should give us 4. 4 plus 8 is 12, plus 0, we have 12. So we're going to write a 2 down here and carry up a 1. 1 plus 8 is 9, plus 6, that's 15. So we have a 5 here, we carry up a 1. 1 plus 8 is 9, plus 0 is 9, plus 6 is 15. So we have a 5 here, we carry up a 1. 1 plus 0 is 1, plus 6, that's 7, plus 0 is 7. We bring that down here. 0 plus 1, 1, plus 2, 3. 0 plus 0 is 0, plus 1 is 1. Now we're going to do the same, we're going to follow the same steps, but in this case we're going to actually carry over in our multiplication steps. So let's get started. So we have 524 multiplied by 514. Okay, so we start from the right hand side right here, and so we have 4 multiplied by 4, that's going to give us 16. So we write a 6 here and we bring up a 1. 2 multiplied by 4, we have a 8, we add that to the 1 here, that gives us a 9. 5 multiplied by 4, we have a 20. So we have a 2096. Then we move over to the hundreds, the tens column rather, the tens column, and we start by putting a 0 in the ones position. So 4 multiplied by 1, we have 4. 2 multiplied by 1, we have 2. 5 multiplied by 1, we have 5. Now we switch over to the hundreds position, and while we're at it, we're going to put zeros in the ones position and in the tens position. So we start multiplying. 4 multiplied by 5, we have 20. So we have a 0 here, and we bring up a 2. 2 multiplied by 5, we have a 10. And then we add 2 to that. Actually, the 2 here should have been right here. So 2 multiplied by 5, we have 10 plus 2, that's going to give us 12. So we write down the 2 here and we bring up the 1. 5 multiplied by 5, we have 25 plus 1, that will be 26. So now we're going to replace all the blanks with 0, all the blank spaces with 0. Okay, and now we can add these numbers together. 6 plus 0 plus 0, that's going to be 6. 9 plus 4, 13 plus 0, that's 13. So we're going to write a 3 here and bring up a 1. 1 plus 0, 1 plus 2, 3 plus 0, 3. 2 plus 5, 7 plus 2, we have a 9. 0 plus 0 plus 6 is a 6. 0 plus 0 plus 2, that's going to give you a 2. Now we have this next question. 156 multiplied by 932. So we'll start from the right hand side. 6 multiplied by 2, that will give you a 12. So you write a 2, carry up a 1. 5 multiplied by 2, that will give you a 10, plus 1, 11. So you write 1 and you carry 1 over here. 1 multiplied by 2, that's 2 plus 1, we have 3. Next, we switch over to the tens position. What that means is, in the ones position, you're going to have a 0. 6 multiplied by 3, we have 18, so we write 8 up here, we carry a 1. 5 multiplied by 3, that's 15, plus 1, we have a 16, so we have 6 here, we carry 1 up here. 1 multiplied by 3, that's 3 plus 1, we have 4. Now we switch over to the hundreds position and we start multiplying. But before we start multiplying, we're going to put a 0 in the ones position, a 0 in the tens position, and we start multiplying. Our numbers are going to be written from the hundred position. 6 multiplied by 9, that will give us 54. So we have a 4, and we bring up a 5 here. 5 multiplied by 9, that's 45, plus 5, that's going to give us 50. So we're going to write a 0 here and bring up a 5. 1 multiplied by 9, that's going to be 9, plus 5, 14. So we write a 4 here, and a 1 here, and then we're going to add them. But before we add, we want to make sure that we replace every blank position with a 0. So I have a 0 here, 0, 0, 0, 0. So we must have 6 digits on each row. 2 plus 0 plus 0, we have 2. 1 plus 8, 9 plus 0, 9. 3 plus 6, 9. Plus 4, 13. So I have a 3 down here, bring up a 1. 1 plus 0, 1 plus 4, 5 plus 0, we have 5. 0 plus 0 plus 4, we have a 4. 0 plus 0 plus 1, we have a 1. Final set of examples. We have 1, 3, 6, 8 multiplied by 4, 5, 2. We'll start on the right hand side here. 8 multiplied by 2, we have 16. So we write 6 and we bring 1 up here. 6 multiplied by 2, we have 12 plus 1, we have 13. So we write 3 and we bring up 1. 3 multiplied by 2, we have 6 plus 1, we have 7. 1 multiplied by 2, we have 2. So we move over to the tens position. And so I'm going to write this in a different color. So we start by putting a 0. Put a 0 in the ones position. So 8 multiplied by 5, we have 40. So we write a 0 down and we carry up a 4. 6 multiplied by 5, we have 30 plus 4. That's going to be 34. So we have 4 here. We carry up a 3. 3 multiplied by 5 is 15 plus 3, 18. So we have 8 and we carry up a 1. 1 multiplied by 5, we have 5 plus 1, we have a 6. Now we switch over to the hundreds position. In the hundreds position, we have to first, we're going to first put a 0 in the ones position and in the tens position. 8 multiplied by 4, we have 32, so we write 2 here and we carry up a 3. 6 multiplied by 4, we have a 24, we add a 3, that's going to give us a 27. 7. So we write a 7, carry up a 2. 3 multiplied by 4, we have 12. And then we add 2 to that. That is going to give us 14. So we have 4 right here, carry up a 1. 1 multiplied by 4, that's going to give us a 4 plus a 1. That's going to give us a 5. Now we're going to replace every blank position with 0. Let's do that here. So we have a 0 here, 0, 0, and then we can add the numbers together. 6 plus 0 plus 0 is going to give us 6. 3 plus 0 plus 0, 3. 7 plus 4, 11 plus 2, 13. So I'm going to write a 3 down here, carry up a 1. 1 plus 2, 3 plus 8, 11 plus 7, 18. I'm going to write an 8 here, carry up a 1. 1 plus 0, 1 plus 6, 7 plus 4, we have 11. So I'm going to write 1 here and carry up a 1. 1 plus 0, 1 plus 0, 1 plus 5, 6. Now finally, we have 8215, 8215 multiplied by 363. So we're going to start multiplying from the right hand side. And so we have 5 multiplied by 3, that's 15. We're going to write a 5 and carry up a 1. 1 multiplied by 3, that's 3 plus 1. We have 4. 2 multiplied by 3, we have 6. 8 multiplied by 3, we have 24. Now we switch to the next column, which is in the tens position. And to do that, we're going to first write a 0 in the ones position. 5 multiplied by 6, we have 30. So we have 0, we carry up a 3. 1 multiplied by 6, we have 6 plus 3, we have a 9. 2 multiplied by 6, we have 12. So we write a 2, carry up a 1. 8 multiplied by 6, that's 48 plus 1, 49. And then we now multiply by the number in the hundreds position. When we do that, we're going to write a 0 in the ones position, in the tens position. And then 5 multiplied by 3, we have 15. So we write 5. We carry up 1. 1 multiplied by 3, we have 3 plus 1, we have 4. 2 multiplied by 3, we have 6. 8 multiplied by 3, we have 24. So now we're going to fill up all the blank spots with zeros. So I'm going to put a 0 here, then 0, 0. And then we're going to add them together. Add them together. 5 plus 0 plus 0, that's a 5. 4 plus 0 plus 0, that's a 4. 6 plus 9, 15 plus 5, 20. So you put a 0 here, you bring up a 2. 2 plus 4, 6. Plus 2, 8. Plus 4, 12. I have a 2, carry up a 1. 1 plus 2, we have 3. Plus 9, 12. Plus 6, 18. So we have a 8 right here, you carry up a 1. 1 plus 0, 1. Plus 4, 5. Plus 4, 9. 0 plus 0, 0 plus 2, we have a 2. So let us introduce exponents. We're going to look at the definition of exponents. We're looking at exponent notation, then exponents and expanded form, exponent and standard form. So an exponent represents the repeated multiplication of the same number. The number that is multiplied is known as the base, and the number of times the number is multiplied is the exponent. So exponent notation, so we say that exponents are expressed as a to the power of b. As we saw earlier, a is the base, that is the number that is going to be multiplied continuously, and b is the number of times that number is multiplied. So for example, if I have 3 multiplied by 3 multiplied by 3 and multiplied by 3, we can see that 3 is a number that keeps getting multiplied and is multiplied 4 times. So that's going to be 3 to the power of 4. We can also have expanded notation. So if I have 4 to the power of 3, what that tells me is that 4 is a number that is going to be multiplied continuously and is going to be multiplied 3 times. So that's 4 times 4 times 4. And then for standard notation, you have 4. When we go to standard notation, that means that we, after expanding, we just simplify the value. So 4 to the power of 3 is 4 times 4 times 4, which is also the same as 64. Let us study long division together. We're going to look at the parts of a division problem. We're going to look at the steps used in long division, and we're going to look at some examples of single-digit divisors and double-digit divisors in long division. And when we look at a division problem, we have the number inside of the division sign is called the dividend. The number on the outside, which you're going to use to divide, is the divisor. Your result is the quotient. And if you have a remainder or a number left that is less than the divisor, that is going to be your remainder. Now let's look at our steps. So we always start from the leftmost number, and you divide the dividend by the divisor, and then we're going to multiply the quotient by the divisor, subtract the product, break down the next digit, and then we're going to repeat steps 2, 3, and 4 until we have a 0 or a digit less than the divisor as a remainder. Now I'm going to show you what all of that stuff means. So we have divide 76 by 4. So let's look at this. 76, we divide that by 4. So we start from the left hand side. So 7 divided by 4. How many groups of 4 can we find in 7? We can see that 4 times 1 is 4 and 4 times 2 is 8. So we have one group of 4 in 7. 1 multiplied by 4, that gives us 4. So we subtract that, and we have 3. Now the next thing we're going to do is bring down the 6. So 36 divided by 4, that should give you 9. 9 times 4 is 36. We subtract again and we have a 0. So that means 76 divided by 4 is equal to 19. We're going to apply the same method for 872 divided by 8. So 8 divided by 8, we have 1. 8 multiplied by 1, we have 8. We subtract, we have a 0 here, so now we bring down a 7. 7 divided by 8, 7 is less than 8, so you will find 0 groups of 8 and 7. 0 multiplied by 8, you have 0, and then we subtract again. 7 minus 0 is 7, and then we bring down the 2. 72 divided by 8, you will get 9. 9 times 8, you have 72. You subtract, you end up with a 0. So 872 divided by 8 equal to 109. So we have 6,320 divided by 8. 6 divided by 8, that's going to give us a 0. So we go over to 63. 63 divided by 8. 8 times 8 is 64. So we're going to have 7 groups of 8 in 63. 7 times 8, we have 56. We subtract, and that's going to give us 7. We bring down the 2. 72 divided by 8, we have 9. 8 times 9, we have 72. So we have a 0 here, and then we bring down this other 0. 0 divided by 8 is 0. So 6,320 divided by 8 is going to be equal to 790. Another way you can look at this is, the most important thing is have your 632 divided by 8 and append the 0 to the end of the result. Now let's try this. 8933 8933 divided by 6. 8 divided by 6, we have that one time. 6 times 1, we have 6. 8 minus 6 is 2. We bring down the 9. 29 divided by 6, we're going to have 4 groups of 6 in 29. 4 times 6 is 24. We have 5 as a result of that subtraction. Next, we bring down a 3. 53 divided by 6, we're going to have 8 groups. 8 times 6 is 48. We subtract again. 53 minus 48, we have 5. Now we have another 3 that we have to bring down. 53 divided by 6, we have 8 again. 8 times 6, we have 48, and we have a remainder of 5. Because we can go no further, we have a remainder of 5. So 8933 divided by 6 equal to 1488. We're going to use R for remainder and then 5. So we're going to look at double-digit division now. It follows the same method. So just follow as I walk you through this example. So we have 984 divided by 12. 9 divided by 12, it's not going to go. Because you have your dividend number being less than your divisor. So we're going to move over to, we're going to append the second digit going towards the right. 98 divided by 12, we should get that 8 times. 8 times 12, we have 96. We subtract, so that gives us 2. We bring down a 4. 24 divided by 12, we have 2. 2 times 12, we have 24. We subtract and we get a 0. So 984 divided by 12 is 82. 1892 divided by 11. So 1 divided by 11, that's not going to work. So we now have 18 divided by 11, we have 1. 1 times 11, we have 11. 18 minus 11, 7. Now we bring down a 9. 79 divided by 11, that's going to happen 7 times. 7 times 11, we have 77. We subtract and we have a 2. Then we have to bring down another 2. So 22 divided by 11, we have that twice. 2 times 11, we have 22. We subtract and we have a 0. So 1892 divided by 11 is 172. So 1985 divided by 10. 1 divided by 10, not going to work. So we have 10 now. 19 divided by 10, we have 1. 1 times 10 is 10. 19 minus 10, that gives you 9. We bring down an 8. 98 divided by 10, that's going to happen 9 times. 9 times 10 is 90. We subtract and we get 8. Now we have to bring down the 5. 85 divided by 10, that's going to happen 8 times. 8 times 10 is 80. We subtract and we have a 5. 5 is less than 10, so we can't go any further, and we have no other numbers to bring down from the original question. So that's going to be our remainder. So 1985 divided by 10 is 198, remainder 5. We'll be discussing slope as rate of change. In this lesson, we're going to describe the rate of change. We're going to also describe slope as the rate of change, and then we're going to look at several examples with rate of change. So the rate of change describes how one quantity changes in relation to another quantity. And we have 3 different types. We have one that is positive, which means that as one variable changes, the other variable changes in the same direction. The negative means that they change in opposite directions, and the neutral means the change in one doesn't really affect the other. Now we have the independent variable and the dependent variable. The independent variable is known as your x-axis or your x variable, or also your horizontal variable, the variable on the horizontal axis, and your dependent is on the y-axis. And we define the rate of change as the change in your dependent variable divided by the change in your independent variable. So we'll look at some examples here. So this table shows the cost of renting a boat. So we want to find the rate of change and what it represents. So the rate of change is change in dependent variable divided by change in independent variable. Dependent variable is y, independent is x. So the change in the dependent variable, we have, I'm going to use this right here for my rate of change. So we have 440 minus 320 divided by 10 minus 7. So this is going to give us $120 and then 3 days. So this is going to give us $40 per day. So the rate of change is 40. Rate of change is $40 per day. So it means that the cost of renting a boat is $40 per day. So the table below shows the cost of a chess club membership, and we're looking at time in months. So we look at the rate of change. So let's look at rate of change is change in y divided by change in x. So we're going to look at this, what we're going to use here. So we have 250 minus 160 divided by 7 minus 4. So this is going to give us 90 over 3. So $90, 3 months. So this is going to be $30 per month. So what this means here, the rate of change is going to be $30 per month, which means for every additional month, the member of this club is going to pay $30. So we have a 12-month membership. So 10 months is $340 for 10 months. So to 12 months, you have 2 months here. And so it's $30 per month. So we're going to add 60 because 2 times 30 is 60. So we're going to have $400 for a 12-month membership. So the graph represents the graph for a hot air balloon flight. What is the rate of change? So we're going to pick a point, doesn't matter what point. We're going to pick this point right here, this right here, and this right here. So rate of change is the change in y divided by change in x. So the change in y is 5,000 minus 3,000 divided by 5 minus 3. So this is going to give us 2,000 over 2. So it's 1,000 feet per minute. So that means that this hot air balloon travels at a rate of 1,000 feet per minute. So what does the rate of change represent? The hot air balloon travels at a rate of 1,000 feet per minute. So that's how you interpret the rate of change values. Now we're going to look at rate word problems. We're going to focus on distance, speed, and time problems, and then we're going to look at work rate problems. So the relationship between distance, rate, and time is given as this. Distance is speed or the rate multiplied by the time. And then rate is the distance divided by time. So distance is speed multiplied by time. And then we can deduce the others. We can say speed is distance divided by time, and time is distance divided by speed. Now let's look at some word problems. Two cars started from the same point at 9 a.m. So they are traveling in opposite directions at 20 and 40 miles per hour respectively. At what time will they be 330 miles apart? So let's kind of try to diagram this. So we have a starting point. Let's call this point A. One car goes in this direction, let's say 40 miles per hour. Another car, and the second car goes in this direction at 20 miles per hour. We want to find out at what point will they be 330 miles per hour apart. So let's look at the distance. Distance is given as speed multiplied by time. So there's going to be a consistent time here. So for we can say this is car 1 and this is car 2. So for car 1, the car 1 would cover a distance of, let's say car 1 distance is 20 miles per hour multiplied by time, which is t. Car 2's distance is going to be 40 miles per hour times t. So to get the distance apart, we're going to add the distance covered by car 1 and the distance covered by car 2. And at that point, we'll be able to determine how far apart they are. So distance covered by car 1 is 20t. Distance covered by car 2 is 40t, and they are 330 miles apart. So 60t is going to be equal to 330. So we divide by 60 on both sides, and so we have T is going to be 5.5 hours, or we can write this as 5 hours and 30 minutes. Now, we want to understand if this is actually valid. So let's multiply 5.5 by 20. So we have 110 miles this way, and for card 2 you have 220 miles this way. So you can see that this right here is 220, this here is 110. So you can see that this car right here and these two cars are about 330 miles apart. But the question is not done. It's asking at what time. So what we're going to do is we're going to add the number of hours, the duration here, to 9 a.m. so we can know what time it would be 5.5 hours from when they started. So this is going to be 9 a.m. and then we add 5.5 hours to this. So this is going to give us 1430 hours. And of course, we can convert. Since it's in AM PM, so we're going to subtract 12 hours, so it's going to be 2:30 p.m. So at 2:30 p.m., if the cars drive at these speeds, they will be exactly 330 miles apart. So John left home and drove at a rate of 45 miles per hour for 3 hours. He stopped for lunch, then drove for another 3 hours at a rate of 55 miles per hour to reach his destination. How many miles did John drive? So let's look at the first distance he covered. Let's look at first part of his journey. He drove 45 miles per hour. So distance is speed multiplied by time. So 45 miles per hour multiplied by 3 hours. So he drove 135 miles the first time. And then for the second part of his journey, so second part, we also know that distance is speed multiplied by time. Second part, he drove 55 miles per hour for 3 hours, which gives us 165 miles. So how many miles did he drive is going to be the sum of the first part of his journey and the second part of his journey. So total distance is going to give us 135 miles plus 165 miles. When you do this addition, you should get 300 miles. So we're going to look at this rate of work problem. It takes 1.5 hours for John to mow the lawn. Linda can mow the same lawn in 2 hours. How long will it take John and Linda working together to mow the same lawn? So for John, it's 1.5 hours for the lawn. For Linda, it's 2 hours. So what we're trying to do, the first thing we're going to do is, what is John's rate of work? So how much of it can he do in 1 hour? So for John, the whole lawn, so let's do this. One lawn takes 1.5 hours. So we want to find out how much of it he can do in 1 hour. So we're going to have 1 over 1.5 of the lawn. So this is the fraction of the work he can do in an hour. So this is going to give us 2/3 of a lawn per hour. Okay, for Linda, she can get through one lawn or one piece of lawn in 2 hours. So we want to find out her rate of work. So this is amount of work she can do in 1 hour is going to be 1/2 of the piece of lawn. Now, we want to find out if they work together, what is their rate of work? So what we're going to do with that is we're going to add up John's rate, which is 2/3, and Linda's rate, which is 1/2. So when they work together, their rate of work is going to be, let's do the fraction here. So this is going to be lowest common denominator of 6. So this is going to be 6, and this is going to be 4/6 plus 3/6, which is going to be 7/6. So if they work together, they can get through 7/6 of the lawn in 1 hour. So if they can get through 7/6 of the lawn in 1 hour, how long will it take them to get through one piece of the lawn? So 7/6 of a lawn can be done in 1 hour. So the whole lawn is going to be 1 divided by 7/6, which is going to be 6/7 of an hour. Now let's look at another example. A tank can be filled by pipe A in 4 hours and by pipe B in 6 hours. When the tank is full, it can be drained by pipe C in 8 hours. If the tank is initially empty and all 3 pipes are open, how many hours will it take to fill up the tank? So let's start with pipe A. Pipe A requires 4 hours. So what is the rate of work? The rate of work for pipe A is, so you have 1 tank, so 4 hours are required to fill 1 tank. So in 1 hour, pipe A fills 1/4 of the tank. Let's look at pipe B. Pipe B requires 6 hours to fill 1 tank. And so in 1 hour, pipe B is going to be able to fill up 1/6 of the tank. Now we have pipe C. Pay attention to what pipe C does. Pipe C is a draining pipe, so that's very important to note. So it requires 8 hours to drain 1 tank, and so in 1 hour it can only drain 1/8 of the tank. So now when they are all working together, so pipe A plus pipe B, but then pipe C is draining, so it's going to be minus. So we have 1/4 plus 1/6 minus 1/8. This is when they work together. So if they're all working together, this is what you should see for the effort in 1 hour. So let's simplify this. So the least common denominator here is going to be 24. So I'm going to have 6/24 plus 4/24 minus 3/24. So this is going to give us 7/24. So when they work together, 7/24 of the tank can be done in 1 hour. So this is showing us that 7/24 of the tank is filled in 1 hour. So we want to find out how long is it going to take to fill up the tank. So the tank is represented by 1. So 1 tank is going to be 1 divided by 7/24. So it's going to give us 24/7, which is 3/7 hours. So if these 3 pipes are working together, it's going to take 3/7 hours for the tank to be full. And take note, it's also taken into account that we have pipes A and B filling up the tank and pipe C draining the tank. So after 3/7 of an hour, the tank will be completely full with all these pipes working together. We're going to look at circle geometry and focus on the area and the perimeter. First of all, we'll look at the radius and diameter of a circle. the area of a circle, and the circumference of a circle. Let's start with the radius of a circle. So the radius of a circle is the distance from the center of the circle to the circumference of the circle. The circumference is the boundary of the circle. So A is at the center, so from A to B is the radius of this circle. The diameter of a circle is the line that passes through the center that joins one end of the circumference to the other end of the circumference. So it has to pass through the center. So what you can simply say is the diameter divides the circle into two equal parts. So in this case, the line AOB is the diameter of the circle. So the circumference of a circle is what we'll call the perimeter of the circle. So that's the path around the circle. So you can look at it as the line that the boundary of the circle is considered your perimeter. And the perimeter is determined as 2 pi r, or which is 2 pi, where pi is a constant, multiplied by the radius, or pi multiplied by diameter. And the reason why this is so is because the radius, diameter divided by 2, or the diameter is 2 times the radius. Let's look at some examples. For all of these examples, I'm going to write the answers in terms of pi because some questions will give you the actual value of pi. So I'm just going to use pi as in all my answers. So what is the circumference of a circle with a radius of 14 centimeters? The circumference is 2 pi multiplied by the radius, which is going to be 2 pi multiplied by 14 centimeters, which is going to give us 28 pi centimeters. What is the circumference of a circle with a diameter of 14 centimeters? The circumference here is pi multiplied by diameter, which is going to be pi multiplied by 14 centimeters, which is 14 pi centimeters. The area of the circle is the size of the surface of the circle. So it's the size of the inside of the circle is going to give us the area of the circle. Now we do that by saying area is pi multiplied by radius squared, and the area is also going to be equal to pi multiplied by diameter squared over 4. And here's how we get to that. Area is pi r squared, which is the same as pi, radius is diameter over 2 squared, which is pi d squared over 4. Now let's apply that in some examples. What is the area of a circle with a radius of 14 centimeters? So the area is pi r squared, which is pi 14 centimeters squared, which is going to give us 196 pi centimeters squared. What is the area of a circle with a diameter of 14 centimeters? So the area is going to be pi d squared over 4, which is going to be pi 14 squared over 4, which is 196 pi centimeters squared over 4, and that gives you 49 pi centimeter squared. The other way you can look at that is diameter is times the radius. And so what we're going to do here is, because area is pi r squared and r is diameter over 2, so we're going to say area is pi r squared, which is pi, then to get the radius we have to divide the diameter by 2 and square that, which is going to give us pi times 7 squared centimeter squared, which is 49 pi centimeter squared. So either way, either approach you take should get you to the same answer. Let's examine place value for decimal numbers. Our focus will be on 1 to 3 decimal places and 4 to 6 decimal places. We'll be starting with 1 to 3 decimal places. A key point here that is different is that we start from left all the way to the right and we have tens. The difference here with the whole numbers is it's the tenth. What that means is that you have a number with 10 in the denominator. For hundreds, you have a number with 100 in the denominator, and for thousandths, you have a number with 1,000 in the denominator. So what that's trying to tell us is, once we get a decimal point, every number after that represents some type of a fraction. So let's apply this to some examples. So what is the place value of the underlined number in the numbers below? So we have 68.412. So here's a trick we're going to use. After the decimal place, let's put our denominator, let's put a line so we can indicate a fraction. So the number, we count the number of places after the decimal place, the decimal point is going to be 1, 2. So the number is in the second place after the decimal point. So we're going to put a 1 out here, and then we're going to put 2 zeros to represent the decimal place. So that's going to give us, this is going to give us 1 over 100. So this is going to be 100th with a th at the end. Now 756.378, we're going to follow the same method. After the decimal point, we're going to put a line to indicate a fraction. So we're going to put a 1 on there. How many places after the decimal do we have that number? We have 1 place, so it's going to be 10. So this is going to be 3 over 10, which is called 3/10. Now 4587.693. So we have a decimal place, so we're going to draw a line and put a 1 under. How many places after the decimal point does this number appear? Is the first place, so it's 1 place. So this is 6 over 10, which is 6/10. And finally, on these examples, we have a decimal point right here, so we have to read it from left to right. So we're going to look at putting a line to indicate we're going to do a fraction here, and we put a 1. How many places after the decimal point? This is 1, 2, 3. So it's 1, 2, 3. So this is 9, and then you have 1,000 in the denominator. So this is going to be 9,000. Okay, so now let's go ahead to 4 to 6 decimal places. Now you can see that as we continue to have more numbers in the decimal, we just continue to increase the number of zeros in the denominator. So if you want to understand some of this, you can look at the whole numbers or the integers that the lesson on whole numbers and integers to see how it goes from right all the way to the left. Here we have tenths. This is divided by 10, hundredth divided by 100, thousandth divided by 1000, 10,000th divided by 10,000, 100,000ths divided by 100,000, and then millionth divided by 1 million. Let's take a look at a few examples. So what I'm going to show you here is whenever you have a decimal point, just draw a line and put a 1 to show that you're going to be dealing with a fraction. Now let's see, this is in the fourth place after the decimal point. So 1, 2, 3, 4 is in the fourth place. So we're going to put 4 zeros at the end in the denominator, and then we put the digit on the numerator. So we have 10,000 in the denominator. So this is going to be 4 10,000ths. Okay, same goes here. We have a decimal point, and the place value for the digit we're interested in is after the decimal point. So we put a line right here. We'll draw a 1. Let's count how many spots after the decimal point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 9 over 100,000. So this is going to be 900,000. Always pay attention to the th at the end of the number. Now we have a line here again because the digit we're interested in is after the decimal point. Let's see, we have 1, 2, 3, 4. So 1 is in the fourth position after the decimal point. So we have 1, 2, 3, 4. We put a comma here. So this is 10,000th. And then we have 1 here. So this is 1 10,000th. And then finally, we draw a line, put a 1, because the digit we're interested in is after the decimal point. So let's see how many spots after the decimal point. It's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're going to replace each of those positions with zeros. And then we have 5 millionths. So this is how you deal with place values for digits or numbers that have decimal points, or digits after the decimal place. For the most part, the 1 to 3 decimal places are more common. The 4 to 6 are just extra, so you understand if you're in a position where you have to deal with numbers that large for precision, you understand how to deal with place value. Let's examine place value, and we're dealing with just integers here. We're going to look at 1 to 3 digit numbers, 4 to 6 digit numbers, and 7 to 9 digit numbers. Let's start with 1 to 3 digit numbers. When we're looking at whole number place values, we're going to start from the right to the left. So ones means that you multiply this by 1. Tens means you multiply this by 10. And then 100 means that you multiply this by 100. What you can see here is as we move from the right to the left, you can see that we are multiplying by a factor of 10. So 1 times 10 is 10, and 10 times 10 is 100. Now let's assume that we had a number like 25. So what that means here is 2 is going to be under the tens and 5 is going to be here. So what it's trying to tell us here is 25 is the same as 2 times 10 plus 5 times 1. That's what it's trying to tell us. And if you see that, this is going to be 20 plus 5, which is 25. So we're going to apply this in some problems and just see how this works together. So what is the place value of 5 in this set of numbers? So remember, we start from the right. The right is ones. The next one towards the left is tens, and the next one towards the left is 100s. So in this case, 5 is the last digit, so we call this ones, and you can say this is the same as 5. In this case, this is ones, this is tens, right here is ones, tens, and then hundreds. 5 is in the hundreds place, so here's how we do it: hundreds, and then we can put 500. And then 5 is in the tens place, so we call it tens, and we have 50. So now we have this set of questions. What is the place value of the underlined number in the following numbers? This is it's in the tens place, so the place value is tens, which represents 40. And here 6 is in the hundreds place, and we have 600. Now let's look at 4 to 6 digit numbers. So we start again from the right. So this is multiplied by 1, multiplied by 10, multiplied by 100, multiplied by 1000, multiplied by 10,000, and multiplied by 100,000. So let's put comma so we can see. So you can see here, the same thing follows. As you go from the right to the left, you're multiplying by a factor of 10. Actually, you're just multiplying by 10. So you can see that through. And if we had a number like 6,000, okay, what that means is we have zeros. So we have 6 times 1,000 plus 0 times 100 plus 0 times 10 plus 0 times 1. So we'll put all these in parentheses, and you can tell that this is indeed 6,000. Now let's look at some problems here. So what is the place value of the underlined number in the following numbers? So let's go for it. So this is 0 is in the ones, this is tens, this is hundreds, this is thousands. So this is going to be thousands, and then you have 8,000. What about in this case? So this is ones, tens, 100, 1,000, 10,000, 100,000. So this is going to be 100,000s. And then we can write that as 900,000. In this case, we have tens, ones, tens, hundreds, 1,000, 10,000. So this is 10,000s. So this is going to be 70,000. Just so you understand what I'm doing, all I'm doing here is I'm multiplying 8 by 1,000. This is 9 by 100,000. And this is 7 by 10,000. Now in this example, 875,329, we have ones, tens, hundreds, thousands. So we have thousands here, and so that's going to give us 5,000, which is 5 times 1,000. Now we have 7 to 9 digit numbers. So we have times 1, this is times 10, times 100, times 1,000, times 10,000, times 100,000 times 1 million. This is times 10 million. And then this is times 100 million. Let's put commas to show this. So we got, notice we put commas after, we start counting from the left and we count 3 digits, put a comma until we get to we start counting from the right, and then we count 3 digits from the right, put a comma until we deal with the whole number. So let's look at this as an example. 1, 2, 3, we put a comma. 1, 2, 3, we put a comma. So this 10 million. Now for 100 million, we have 1, 2, 3, put a comma. 1, 2, 3, we put a comma. So that's 100 million. What is the place value of the underlined number in the numbers below? So we start with ones, tens, hundreds, thousand, 10,000, 100,000, 1 million, 10 million. So this is going to be 10 million, and we're going to have 40 million, and so that is same as 4 times 10 million. Here we have ones, tens, hundreds, thousand, 10,000, 100,000, and then 1 million. So this is going to be millions, and we're going to have 6 million. So that's 6 times. Now, in this example here, 6 is in the ones place. This is 1 is in the tens place. 4 is in the hundreds place. 9 is in the thousand place. 0 is in the 10,000 place. 7 is in the 100,000 place. 6 is in the millions place. 5 is in the 10 million place. So 10 millions. So that's 5 times 10 millions, which is going to give us 50 million. Finally, we start again from the right hand side. This is ones, tens, hundreds, thousand, 10,000, 100,000, million, 10 million, 100 million. So this is going to be 100 millions. And what we have here is 700 million in parentheses, which is the same as 7 times 100 million. So these are the general place values for whole numbers, or let's use whole numbers here, that have between 1 and 9 digits. We're going to look at the distance between points, and our focus will be the distance between any 2 points on the coordinate plane. So if we have points A, x1, y1, and B, x2, y2, the distance between those 2 points is going to be given as the square root of x2 minus x1 squared, or plus y2 minus y1 squared. Also, because you have a squared, you can also write it this way as the square root of x1 minus x2 squared plus y1 minus y2 squared for the distance. So we're going to apply that to a few problems just to show how this works. So find the distance between points A, 5, 3 and points B, 8, 3. So we're going to have our formula. R is square root of x2 minus x1 squared plus y2 minus y1 squared. So x2 minus x1 squared, so let's put that square root sign out here. X2 minus x1, I'm going to assume this is the point. I'm going to use B as the point with the x2 and the y2, and A as the point with the x1 and y1. So x2 minus x1 squared, so 8 minus 5 squared plus y2 minus y1 squared, 3 minus 3 squared. So we have a square root of 3 squared plus 0, which is the square root of 9, and that's going to give us 3. So R is going to be equal to 3 units of measurement. Another example. What is the distance between the point A42 and the point B16? So R is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to start with, I'm going to use B as the x2 and y2. So that's going to give us 1 minus 4 squared plus 6 minus 2 squared. So this is going to give us square root of negative 3 squared plus 4 squared. Now we're going to have negative 3 squared is 9, 4 squared is 16, which is square root of 9 plus 16 is 25, and the square root of 25 is 5. So the distance between those 2 points is 5 units. Another example. R is going to be square root of, you notice that I make it a habit of writing my formula first, or my equation first, so that it can guide me while I walk through all the problems. So now let's plug in the numbers. R is going to be square root of x2 minus x1 minus 5 minus 3 squared plus y2 minus y1. So it's going to give us, so minus 5 minus 3 squared. So this is going to be our x2, y2. This is our x1, y1. So you can switch them. And then y2 minus y1 is minus 4 minus 8 squared. Minus 5 minus 3 squared is minus 8 squared. Minus 4 minus 8 is going to give us positive 4 squared. So this is going to give us square root of 64 plus 16, which is the square root of 80. Now what we're going to do here, so R is the square root of 80 units. Now what we're going to do is we're going to write this in radical form and simplify this radical. So let's look at 80. Let's decompose 80. We divide by 2 and we get 40. Now we have 40, we decompose that, divide by 2, we get 20. And 20 decompose that, we divide by 2, we get 10. We decompose 10, we divide by 2, and we get 5. So we can see here, I'm going to group them in pairs. So we have 2 here, and so for this pair, I have 2 in that pair. I have 2 also here, so this is going to give me, and this is a single right here, so R is going to give me 4 square root of 5 units. If you need any help with this, there's a there's a topic on radicals. Now finally, let's write the formula first. R is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug in values. R, so x2 minus x1 minus, so square root of minus 6 minus minus 1 squared plus y2 9 minus minus 3 squared. So so this is going to give us square root of minus 6 minus minus 1. That's going to give us minus 5 squared plus 9 minus minus 3. That's going to give us 12 squared. So this is square root of 25 plus 144, which is going to give us square root of 169. So R is 13 units. So these are the steps we follow to find the distance between 2 points on the same coordinate plane. We're going to look at how to identify the equation of a line that passes through 2 given points. First, we're going to review the slope of a line given 2 points, and then we're going to derive the equation of the line using those 2 points. So the slope of a line with 2 known points, if a line passes through points A, x1, y1, and B with coordinates x2, y2, the slope m is going to be equal to y2 minus y1 over x2 minus x1. Let's apply that to this question here. What is the slope of a line passing through points P, 8, 7, and Q, negative 3, negative 4? So slope is going to be y2 minus y1 minus 4 minus 7 divided by x2 minus x1 minus 3 minus 8. This is going to give us negative 11 in the numerator, and negative 3 minus 8 is negative 11 as well. So the slope is equal to 1. Now, what if we have 2 points that are on a line or are part of a line, and we want to find out the equation of a line that passes through those 2 points? What we're going to end up with is y minus y1 is equal to m multiplied by x minus x1, where m is the slope. Now you can rewrite this as y minus y1 equal to y2 minus y1 over x2 minus x1. You notice that that is the equation for the slope right there. So this is the equation for the slope multiplied by x minus x1. So let's look at this example. What is the equation of a line passing through points A, 9, 6 and B, 3, 12? So first thing I'm going to do is try to get the slope. So slope m is equal to y2 minus y1 divided by x2 minus x1. So that's 3 minus 9. So this is going to give us 12 minus 6 is 6. 3 minus 9 is negative 6. So you divide this and you get negative 1. So now the equation of the line is going to be y minus y1 equal to mx minus x1. So y, what is y1? We're going to use 6 for that, equal to m is negative 1, x minus x1. x1 is 9. So let's simplify this. So y minus 6 equal to negative x plus 9. Let's add 6 to both sides. So y is equal to negative x plus 15. So that is the equation of this line. What is the equation of a line passing through points P5, negative 5, 1 and Q, 7, 8? Let's find the slope. Slope is y2, let's write the equation, y2 minus y1 over x2 minus x1. y2 is 8 minus 1, which is y1, divided by 7, which is x2 minus, and then x1 is negative 5. 8 minus 1 is 7. 7 minus 5 is 12. So now we write our equation. Y minus y1 equal to m of x minus x1. So y minus y1 is 1 is equal to m, which is 7 over 12, and then x minus x1, which is negative 5. So we can rewrite this as y minus 1 equal to 7 over 12 x plus 5. So let's simplify. I'm going to bring this over here. So y minus 1 is equal to 7 over 12 x plus 35 over 12. So we're going to add 1 to both sides. So y equal to 7 over 12x plus 35 over 12 plus 12 over 12. Therefore, y is going to be equal to 7 over 12x plus 47 over 12. Now, what is the equation of a line passing through points R, 0, 5 and S, 4, 0? Let's get the slope. Slope m equal to y2 minus y1 over x2 minus x1, which is going to be equal to y2 is 0 minus y1 is 5 divided by x2, 4 minus 0, which is x1. 0 minus 5 is negative 5. 4 minus 0 is 4. So our slope is negative 5 over 4. Now, the equation of the line is going to be y minus y1 equal to mx minus x1. So let's substitute. Y minus y1 is going to be 5. M is going to be negative 5 over 4, and then x minus x1 is 0. So this is y minus 5 is equal to negative 5 over 4x. So we're just going to add 5 to both sides. So that's going to give us y is equal to negative 5 over 4x plus 5. So this is the equation of the line that passes through 0, 5 and 4, 0. So now we're going to look at how to get the equation of a line using the slope and the intercept. First of all, we're going to review the slope of a line given 2 points, and then we're going to determine the equation of a line using the slope and intercept. So we're told that if we have a line that passes through points A with coordinates x1 and y1, and B with coordinates x2 and y2, the slope is going to be the y2 minus y1 over x2 minus x1. Now let's apply that to this scenario. We have, what is the slope of a line passing through points P, 1, 2, and Q, negative 3, negative 4. So our slope, some would like to say is m, so we'll put m in parentheses, is equal to y2. It doesn't matter which one you make y2, it could be q or it could be p. So let's make py2. So that's 2 minus 4 divided by 1 minus 3. So this is going to be 2 plus 4 divided by 1 plus 3, which is 6 over 4. And when we simplify that, we get 3 over 2. Let's do the reverse, where we make q p2. We make q y2, have the y2 coordinate. So that's minus 4 minus 2, x2 minus x1, minus 3 minus 1. Minus 4 minus 2 is minus 6, minus 3 minus 1 is minus 4. This crosses out, you still get 3 over. Now, if we have a line, or we're trying to get the equation of a line when we have the slope and the intercept, the equation of the line is y equal to mx plus b, where m represents the slope and b represents the intercept. Now let's apply that in some questions. What is the equation of a line with a slope m equal to 4 and intercept equal to minus 6? We know that y equal to mx plus b. So y is going to be equal to, our slope is 4x plus negative 6. So y is going to be equal to 4x minus 6. Finally, what is the equation of a line passing through points P67 and Q33 and an intercept of 4? So we're going to do this. First, we'll find the slope, m equal to 3 minus 7 over 3 minus 6. We have negative 4 divided by negative 3, which is going to be 4 over 3. But we have a y equal to mx plus b. So our slope is 4 over 3 x plus 4. Now you can leave it as this actually, or you can rewrite it if you prefer. Depends on the way that the answer is expected. This is perfectly fine. Some may go as far as saying 3y equal to 4x plus 12. That's multiplying every term in this equation by 3 to get rid of the fraction. And this is also perfectly fine. My hunch tells me that most tests will prefer this response here, where you have y equal to mx plus b. I will be showing you how to multiply